VY Canis Majoris is one of the largest known stars in the universe. This colossal celestial body is classified as a red hypergiant star located in the constellation Canis Major, approximately 5,000 light-years from Earth. Its sheer size is almost beyond comprehension, with a radius estimated to be around 1,400 times that of our Sun. To put this into perspective, if VY Canis Majoris were placed at the center of our solar system, its surface would extend beyond the orbit of Jupiter. This means that it would engulf Mercury, Venus, Earth, Mars, and the asteroid belt entirely. The star's volume is so immense that it could contain more than 9 billion suns. Despite its enormous size, VY Canis Majoris is not very dense. Its mass is estimated to be only about 17 to 25 times that of our Sun, which is relatively low compared to its volume. This is because red hypergiants have expanded outer layers, resulting in a much lower overall density than smaller stars. VY Canis Majoris is nearing the end of its life cycle. It is losing mass at a rapid rate, expelling vast amounts of material into space. This process creates a complex, asymmetric nebula around the star, which astronomers continue to study to better understand the life and death of these cosmic giants. VY Canis Majoris resides in the constellation Canis Major, which translates to Great Dog in Latin. This massive star can be found in the northern part of the constellation, not far from the bright star Sirius, also known as the Dog Star. While Sirius is easily visible to the naked eye, VY Canis Majoris is much fainter and requires a telescope to observe. Canis Major is most visible in the winter months for observers in the northern hemisphere, appearing in the southern sky. The constellation takes the shape of a dog, with Sirius marking the dog's nose or chest. VY Canis Majoris is located near what would be considered the dog's neck area. Despite its enormous size, VY Canis Majoris is challenging to spot due to its great distance from Earth, estimated to be around 3,900 light-years away. This vast separation means that the light we see from the star today actually left its surface nearly 4,000 years ago, offering us a glimpse into the cosmic past. The discovery of VY Canis Majoris dates back to the early 19th century. French astronomer Jérôme Lalande first catalogued this extraordinary star in his star charts in 1801. At the time, Lalande simply recorded it as a faint star, without realizing its true nature or immense size. It wasn't until the 1920s that astronomers began to understand the remarkable characteristics of VY Canis Majoris. Paul Willard Merrill, an American astronomer, observed its unusual spectrum and classified it as a very luminous M-type star. This classification hinted at its extraordinary nature, but the full extent of its size remained unknown for decades. The true enormity of VY Canis Majoris only became apparent in the late 20th century with advancements in observational techniques. Astronomers used interferometry and other sophisticated methods to measure its size more accurately. These observations revealed that VY Canis Majoris was one of the largest known stars in the universe, far exceeding initial estimates. This gradual process of discovery highlights how our understanding of celestial objects evolves with technological progress. What began as a simple star catalogue entry has become one of the most intriguing and extreme objects in our galaxy, captivating astronomers and the public alike with its sheer scale and complexity. VY Canis Majoris is the name of a remarkable star in our galaxy. The first part, VY, is a designation from a catalogue of variable stars, indicating that this star's brightness changes over time. Canis Majoris refers to the constellation in which the star is located, known as Canis Major, or the Great Dog. This celestial giant is a hypergiant star, one of the largest known stars in the Milky Way. Its immense size is difficult to comprehend, with a radius that, if placed at the center of our solar system, would extend beyond the orbit of Jupiter. The star's name, while scientific in nature, belies its extraordinary characteristics. VY Canis Majoris is not just large, it's also highly luminous and unstable. Its variable nature, reflected in the VY designation, is due to its advanced stage of stellar evolution, causing fluctuations in its brightness and size. Despite its impressive name and status, VY Canis Majoris is challenging to observe with the naked eye due to its great distance from Earth. However, its study continues to provide valuable insights into the life cycles of massive stars and the extreme physics at play in the universe. VY Canis Majoris dwarfs our Sun in a way that stretches the imagination. This hypergiant star is one of the largest known stars in the universe, with a radius estimated to be around 1,500 times that of our Sun. To put this into perspective, if VY Canis Majoris were placed at the center of our solar system, its surface would extend beyond the orbit of Jupiter. The sheer scale of this celestial giant becomes even more apparent when we consider its volume. VY Canis Majoris could contain billions of suns within its boundaries. Its mass, however, is not as extreme as its size might suggest, estimated to be only about 17 to 25 times that of our Sun. This enormous star is also notable for its brightness. VY Canis Majoris shines with the luminosity of hundreds of thousands of suns, making it one of the most luminous stars known. Despite its immense size and brightness, it appears dim to us on Earth due to its vast distance, approximately 3,900 light-years away in the constellation Canis Major. The existence of stars like VY Canis Majoris challenges our understanding of stellar physics and evolution. These hypergiant stars are rare and short-lived, representing a brief but spectacular phase in the life cycle of the most massive stars in the universe. Their study provides valuable insights into the extremes of stellar formation and the ultimate fate of these cosmic behemoths. VY Canis Majoris earns its reputation as a monster star due to its sheer enormity and power. This hypergiant star dwarfs our Sun in every conceivable way, making it one of the largest known stars in the universe. The monstrous nature of VY Canis Majoris is not just about its size. This stellar behemoth releases energy at a rate that staggers the imagination, shining with the luminosity of several 100,000 suns. Its immense gravitational pull and intense stellar winds shape the surrounding space, creating vast clouds of gas and dust that stretch for light years. Despite its current grandeur, VY Canis Majoris is nearing the end of its life. As it burns through its fuel at an astounding rate, it sheds enormous amounts of mass into space. This process will eventually lead to its demise in a spectacular supernova explosion, further cementing its status as a monster among stars. The study of stars like VY Canis Majoris pushes the boundaries of our understanding of stellar physics. These cosmic giants challenge our theories about star formation and evolution, serving as extreme examples that help astronomers refine their models of the universe. VY Canis Majoris is classified as a hypergiant star, specifically a red hypergiant. This extraordinary celestial object is one of the largest known stars in our galaxy, dwarfing our Sun in both size and luminosity. Red hypergiants represent a rare and extreme stage of stellar evolution, occurring when massive stars near the end of their lives. These colossal stars are characterized by their enormous size, cool surface temperatures, and intense stellar winds. VY Canis Majoris, in particular, is so immense that if it were placed at the center of our solar system, its surface would extend beyond the orbit of Jupiter. Its vast size is a result of its outer layers expanding as the star progresses through its late evolutionary stages. Despite its cool surface temperature compared to many other stars, VY Canis Majoris emits an incredible amount of energy due to its sheer size. It shines with the luminosity of hundreds of thousands of suns, making it one of the most intrinsically bright stars known. This intense energy output, combined with powerful stellar winds, causes the star to lose mass at a rapid rate. The study of stars like VY Canis Majoris provides valuable insights into the life cycles of the most massive stars in the universe. These rare hypergiants represent a fleeting phase of stellar evolution, offering astronomers a unique opportunity to observe and understand the extreme processes that occur in the final stages of a giant star's life before it ultimately meets its fate in a spectacular supernova explosion. VY Canis Majoris, one of the largest known stars in our galaxy, is estimated to be relatively young in stellar terms. Astronomers believe this hypergiant star is between 8 million and 9 million years old. This might seem ancient from a human perspective, but in the cosmic timeline, it's merely a blink of an eye. To put this into context, our Sun is about 4.5 billion years old, making it roughly 500 times older than VY Canis Majoris. Despite its youth, VY Canis Majoris has already entered the final stages of its life cycle due to its enormous mass and intense energy output. The rapid aging of such massive stars is a fascinating aspect of stellar evolution. While smaller stars like our Sun can live for billions of years, giants like VY Canis Majoris burn through their fuel at an astonishing rate. This accelerated life cycle means that VY Canis Majoris will likely end its life in a spectacular supernova explosion within the next 100,000 to 1 million years. VY Canis Majoris is a colossal red hypergiant star that dwarfs our Sun in both size and mass. Astronomers estimate its mass to be between 30 and 40 times that of our Sun. To put this into perspective, if we were to replace our Sun with VY Canis Majoris, its surface would extend beyond the orbit of Jupiter, engulfing Mercury, Venus, Earth, Mars, and the asteroid belt in the process. Despite its enormous size, the mass of VY Canis Majoris is not as extreme as one might expect. This is because red hypergiants are relatively diffuse, with their matter spread out over a vast volume. The star's immense size is primarily due to its expanded outer layers, which have become less dense as the star has evolved. The precise mass of VY Canis Majoris is challenging to determine due to its distance from Earth and the complexity of studying such massive stars. However, the estimated range of 30 to 40 solar masses represents the current scientific consensus based on observations and stellar evolution models. Understanding the mass of stars like VY Canis Majoris is crucial for astronomers studying the life cycles of massive stars and their eventual fates. These cosmic giants provide valuable insights into the extremes of stellar physics and the processes that shape our universe. VY Canis Majoris, one of the largest known stars in our galaxy, lies at an immense distance from Earth. This colossal red hypergiant star is located approximately 3,900 light-years away from our planet. To put this vast distance into perspective, it means that the light we see from VY Canis Majoris today actually left the star about 3,900 years ago, around the time of the ancient Egyptian Middle Kingdom. This enormous separation highlights the incredible scale of our Milky Way galaxy. Despite being one of the largest stars we know of, VY Canis Majoris appears as just a faint point of light in our night sky, visible only through powerful telescopes. Its great distance also makes it challenging for astronomers to study in detail, requiring advanced observational techniques and instruments to unravel its mysteries. The remoteness of VY Canis Majoris serves as a reminder of the vast expanses of space that separate celestial objects. Even within our own galaxy, stars can be separated by distances that are difficult for the human mind to comprehend fully. This immense star, hundreds of times larger than our Sun, demonstrates the diverse and extreme nature of stellar objects scattered throughout the cosmos. VY Canis Majoris is a stellar behemoth that dwarfs our Sun in comparison, let alone Earth. This hypergiant star is one of the largest known stars in the universe, with a radius estimated to be around 1,500 times that of our Sun. To put its immense size into perspective, if we were to consider how many Earths could fit inside this cosmic giant, the number is staggering. Calculations suggest that approximately 9.6 quadrillion Earths could fit within the volume of VY Canis Majoris. This number is so large it's difficult to comprehend. To break it down, imagine filling a sphere the size of VY Canis Majoris with Earths packed tightly together. You would need to repeat this process millions of times to even approach the number of Earths that could theoretically fit inside this star. You would need to repeat this process millions of times to even approach the number of Earths that could theoretically fit inside this star. The sheer scale of VY Canis Majoris highlights the incredible diversity of stellar objects in our universe. It serves as a reminder of how small our planet is in the grand cosmic scale, yet how remarkable it is that we can observe and study such enormous celestial bodies from our tiny vantage point in space. VY Canis Majoris, one of the largest known stars in our galaxy, would dwarf our solar system if it replaced the Sun. This red hypergiant star is so immense that it would extend far beyond the orbit of Mars, engulfing Mercury, Venus, Earth, and the red planet entirely. To put its size into perspective, if VY Canis Majoris were at the center of our solar system, its surface would reach somewhere between the orbits of Jupiter and Saturn. This means the star would consume the first 4 planets and the asteroid belt, fundamentally altering the structure of our cosmic neighborhood. The sheer scale of VY Canis Majoris is difficult to comprehend. Its radius is estimated to be around 1,300 times that of our Sun. This translates to a volume millions of times greater than our home star, highlighting the incredible diversity of stellar objects in the universe. It is important to note that if such a massive star were to replace our Sun, life as we know it on Earth would be impossible. The intense heat and radiation from VY Canis Majoris would be overwhelming, and the gravitational effects would completely disrupt the orbits of the remaining planets in our solar system. VY Canis Majoris stands out as one of the largest known stars in the universe, dwarfing most other stellar objects. This red hypergiant star is so enormous that if it were placed at the center of our solar system, its surface would extend beyond the orbit of Jupiter. To put this into perspective, it would engulf Mercury, Venus, Earth, Mars, and the asteroid belt with room to spare. Compared to our Sun, VY Canis Majoris is truly colossal. Its volume is estimated to be more than 1 billion times greater than that of our home star. This means you could fit over 1 billion suns inside VY Canis Majoris with space left over. Even when compared to other giant stars, it remains exceptional. It is several times larger than famous giants like Betelgeuse and Antares. The sheer scale of VY Canis Majoris challenges our understanding of stellar physics. Its enormous size pushes the boundaries of what we thought possible for star formation and evolution. Scientists continue to study this cosmic behemoth to better understand the limits of stellar growth and the life cycles of the largest stars in the universe. Despite its incredible size, VY Canis Majoris is not alone in the realm of hypergiants. Stars like UY Scuti and RW Cephei rival its dimensions, showcasing the diverse and extreme nature of stellar objects in our vast cosmos. These giants serve as cosmic laboratories, helping us unravel the mysteries of stellar evolution on the grandest scale. VY Canis Majoris is a hypergiant star of staggering proportions. Its circumference is truly mind-boggling, measuring approximately 7 billion kilometers. To put this into perspective, if we were to replace our Sun with VY Canis Majoris, its surface would extend far beyond the orbit of Jupiter. This colossal star is one of the largest known stars in our galaxy, with a radius about 1,400 times that of our Sun. Its immense size means that light takes several hours to travel from one side of the star to the other, a journey that takes just over 4 seconds for our Sun. The sheer scale of VY Canis Majoris challenges our understanding of stellar formation and evolution. Its enormous size raises questions about the upper limits of stellar mass and the processes that allow such gigantic stars to form and exist. As we continue to study this cosmic behemoth, we gain new insights into the life cycles of the most massive stars in our universe. Imagine a journey around one of the largest known stars in our galaxy, VY Canis Majoris. This red hypergiant star is so immense that it defies easy comprehension. If we were to fly a commercial airplane around its equator, the trip would take an astonishing amount of time. A typical commercial airliner cruises at about 500 miles per hour. At this speed, circumnavigating VY Canis Majoris would take approximately 1,100 years. That is more than the time that has passed since the Norman conquest of England in 1066. To put this into perspective, if we had started this flight during the Roman Empire, we would still be flying today. The sheer scale of this star becomes even more apparent when we consider that a flight around Earth at the equator would take just under 2 days. This mind-boggling comparison highlights the vast differences in scale within our universe. From our tiny Earth to the enormous VY Canis Majoris, the cosmos continues to amaze us with its diversity and immensity. The gravity at the surface of VY Canis Majoris is remarkably different from Earth's gravity, presenting a fascinating contrast between our home planet and this colossal star. VY Canis Majoris is one of the largest known stars in the universe, with a radius estimated to be around 1,500 times that of our Sun. Despite its enormous size, the gravity at its surface is actually much weaker than Earth's. This counterintuitive phenomenon occurs because VY Canis Majoris is incredibly diffuse. Its immense volume is filled with gas that is far less dense than the materials composing Earth. The star's mass is spread out over such a vast area that the gravitational pull at its surface is estimated to be only about 1/30th of Earth's surface gravity. If a person could stand on the surface of VY Canis Majoris, which is impossible due to its extreme temperatures and gaseous nature, they would feel incredibly light. Objects would fall much more slowly, and it would be easy to jump to great heights. However, the intense radiation and heat would make any such hypothetical visit instantly fatal. This weak surface gravity also contributes to VY Canis Majoris's ongoing mass loss. The star is shedding material into space at a rapid rate, forming a large nebula around itself. This process is part of the star's evolution and will eventually lead to dramatic changes in its structure and composition. VY Canis Majoris, one of the largest known stars in our galaxy, boasts an astounding surface area that dwarfs our imagination. If we were to calculate its surface area, we would find it to be roughly 5 billion times that of our Sun. To put this into perspective, imagine a sphere so vast that it would take light itself nearly 8 hours to complete a single journey around its circumference. This hypergiant star, located in the constellation Canis Major, stretches to a radius about 1,400 times larger than our Sun. Its immense size means that if it were placed at the center of our solar system, its surface would extend beyond the orbit of Jupiter, engulfing Mercury, Venus, Earth, Mars, and the asteroid belt in the process. The sheer scale of VY Canis Majoris challenges our understanding of stellar physics. Its surface is not a solid boundary, but rather a vast, turbulent region where the star's energy is finally released into space. This enormous surface area allows the star to radiate an incredible amount of energy, making it one of the most luminous stars known to astronomers. Despite its current grandeur, the fate of VY Canis Majoris is sealed. Stars of this size live fast and die young, and in astronomical terms, this cosmic behemoth is already approaching the end of its life. Its enormous surface area will continue to expand as the star enters its final stages, eventually dispersing its outer layers into space and enriching the cosmos with heavy elements forged in its core. VY Canis Majoris is a stellar behemoth that dwarfs our Sun in comparison. This hypergiant star, located in the constellation Canis Major, is one of the largest known stars in the universe. Its sheer size is difficult to comprehend. But to put it into perspective, if we were to hollow out VY Canis Majoris, we could fit approximately 7 billion suns inside it. This enormous star's radius is estimated to be around 1,500 times that of our Sun. If VY Canis Majoris were placed at the center of our solar system, its surface would extend beyond the orbit of Jupiter. The volume of this cosmic giant is so vast that it could encompass a significant portion of our solar system. The immense size of VY Canis Majoris is a testament to the diverse range of stellar objects in our universe. While our Sun is an average-sized star, VY Canis Majoris represents the extreme end of stellar proportions. Its existence challenges our understanding of stellar formation and evolution, prompting scientists to refine theories about the life cycles of massive stars. Despite its current grandeur, VY Canis Majoris is nearing the end of its life. As a red hypergiant, it has already begun to shed its outer layers, creating a vast nebula around itself. Eventually, this colossal star will likely end its life in a spectacular supernova explosion, leaving behind a black hole as a remnant of its once immense presence in the cosmos. VY Canis Majoris is a hypergiant star of staggering proportions. Its immense size dwarfs our Sun, making it one of the largest known stars in the universe. To grasp its sheer enormity, we can compare it to our own planet Earth. If VY Canis Majoris were hollow, it could contain an astonishing number of Earths within its volume. Current estimates suggest that approximately 7 quadrillion Earths could fit inside this colossal star. That's 7 million billion Earths, a number so vast it challenges our ability to comprehend. To put this into perspective, imagine our entire solar system. Now, picture that solar system filled entirely with Earths, packed tightly together. You would need millions of such Earth-filled solar systems to match the volume of VY Canis Majoris. This comparison highlights the incredible scale of stellar objects in our universe and the vast differences in size between planets and massive stars. The immense size of VY Canis Majoris also hints at its eventual fate. Stars this large are rare and short-lived, burning through their fuel at an incredible rate. In time, this giant will meet a spectacular end, likely as a hypernova, briefly outshining entire galaxies before collapsing into a black hole. VY Canis Majoris, a red hypergiant star, is one of the largest known stars in our galaxy. Its immense size directly influences its extraordinary luminosity, making it one of the brightest stars we can observe. The sheer volume of VY Canis Majoris means it contains an enormous amount of fuel for nuclear fusion. This abundant fuel supply allows the star to burn with incredible intensity, generating a tremendous amount of energy that radiates outward as light and heat. The star's vast surface area also plays a crucial role in its brightness. With such an expansive surface, VY Canis Majoris emits light from a much larger area compared to smaller stars, significantly boosting its overall luminosity. Interestingly, the size of VY Canis Majoris also affects its temperature. Despite its intense energy output, the star's surface is relatively cool for a star, glowing at a reddish-orange color. This lower temperature is a result of the energy being spread out over such a large surface area. However, the sheer scale of the star more than compensates for this lower temperature, allowing it to outshine many hotter, smaller stars. The relationship between size and luminosity in VY Canis Majoris demonstrates the complex interplay of factors that determine a star's brightness. Its vast size not only provides abundant fuel for nuclear fusion, but also creates an enormous radiating surface, resulting in a luminosity that outshines millions of suns combined. The surface temperature of VY Canis Majoris is surprisingly cool for such a massive star. This red hypergiant, one of the largest known stars in our galaxy, has a surface temperature of about 3,000 degrees Celsius. While this might seem incredibly hot by earthly standards, it is actually quite cool compared to many other stars. For context, our Sun has a surface temperature of about 5,700 degrees Celsius, nearly twice as hot as VY Canis Majoris. This cooler temperature is why VY Canis Majoris appears red rather than white or blue. Its enormous size compensates for the lower temperature, allowing it to shine with the brightness of hundreds of thousands of suns. The relatively low surface temperature of VY Canis Majoris is a result of its advanced stage of stellar evolution. As massive stars age, they expand and cool, becoming red supergiants or hypergiants. VY Canis Majoris has swollen to such an immense size that its surface layers are far from its hot core, resulting in this cooler outer temperature. Despite its cool surface, the interior of VY Canis Majoris is incredibly hot, with temperatures reaching millions of degrees. This extreme internal heat drives the powerful stellar winds that cause the star to lose mass at a tremendous rate, shaping its eventual fate as one of the largest known stars in our galaxy, is actually cooler than that of our Sun. While this might seem counterintuitive given the star's enormous size, it's a characteristic feature of red hypergiant stars like VY Canis Majoris. Our Sun, a relatively small and stable star, has a core temperature of about 15 million degrees Celsius. This intense heat is necessary for the nuclear fusion reactions that power our star. In contrast, the core of VY Canis Majoris is estimated to be around 3 to 4 million degrees Celsius. This lower temperature is due to the different stages of stellar evolution. VY Canis Majoris is nearing the end of its life, having exhausted much of its hydrogen fuel. Its enormous size is a result of its outer layers expanding and cooling as it approaches the supernova stage. Despite its cooler core, VY Canis Majoris is far more luminous than our Sun due to its immense size. The star's vast surface area radiates an incredible amount of energy, making it one of the brightest stars known, even though its core burns at a lower temperature than our familiar yellow dwarf star. VY Canis Majoris, one of the largest known stars in our galaxy, is a hypergiant star nearing the end of its life. At its core, this colossal star is primarily fusing helium into carbon and oxygen. This process, known as helium fusion, occurs when a star has exhausted its supply of hydrogen in its core. The intense heat and pressure at the center of VY Canis Majoris allow for this fusion process to take place. As helium nuclei collide and combine, they form heavier elements, releasing enormous amounts of energy in the process. This energy production helps to maintain the delicate balance between gravity pulling inward and the outward pressure of fusion, keeping the star stable for now. However, the fate of VY Canis Majoris is sealed. As it continues to fuse helium, it will eventually begin to produce even heavier elements like neon and magnesium. This progression through increasingly heavy elements is a hallmark of massive stars in their final stages of life, leading ultimately to their dramatic demise as supernovae. The fusion processes occurring in the core of VY Canis Majoris offer a glimpse into the life cycles of the most massive stars in our universe, showcasing the incredible cosmic forges that create the elements necessary for life as we know it. The sheer enormity of VY Canis Majoris profoundly influences its internal structure, setting it apart from smaller stars in fascinating ways. This hypergiant star, one of the largest known in our galaxy, experiences unique physical processes due to its immense size and mass. At its core, VY Canis Majoris generates energy through nuclear fusion, like other stars. However, the extreme gravitational forces created by its enormous mass cause the core to be incredibly dense and hot. This intense environment leads to more rapid fusion reactions, burning through the star's fuel at an accelerated rate. The vast size of VY Canis Majoris also affects its outer layers. Unlike smaller stars with clearly defined boundaries, this hypergiant has an extended, tenuous atmosphere that gradually thins out into space. This diffuse outer region is so large that if placed at the center of our solar system, it would extend beyond the orbit of Jupiter. The star's immense size also leads to instability. Powerful convection currents move enormous amounts of material throughout its structure, causing the star to pulsate and eject matter into space. These processes contribute to the formation of a complex, dynamic environment around VY Canis Majoris, filled with dust and gas that obscure our view of the star itself. Convection plays a crucial role in the energy transfer within VY Canis Majoris, one of the largest known stars in our galaxy. This red hypergiant star, with a radius over 1,000 times that of our Sun, relies heavily on convection to move energy from its core to its outer layers. In the immense interior of VY Canis Majoris, the extreme temperatures and pressures create an environment where convection becomes the dominant mode of energy transport. Massive bubbles of hot plasma rise from the star's core, carrying energy towards the surface. As these bubbles reach cooler regions, they release their heat and sink back down, creating a continuous cycle of energy transfer. This convective process is far more efficient in VY Canis Majoris than in smaller stars like our Sun. The star's enormous size and lower density allow for larger convection cells, which can transport energy more effectively across greater distances. This efficient energy transfer is crucial for maintaining the star's structure and preventing it from collapsing under its own gravity. The powerful convection currents in VY Canis Majoris also contribute to its irregular shape and variable brightness. As enormous plumes of hot material rise to the surface, they create upheavals and distortions in the star's outer layers, resulting in its distinctively bloated and asymmetrical appearance. This dynamic process showcases the intricate relationship between a star's internal energy transfer mechanisms and its observable characteristics. VY Canis Majoris, one of the largest known stars in our galaxy, exhibits a fascinating relationship between its enormous size and its rotation rate. This behemoth star, with a radius over 1,000 times that of our Sun, spins much more slowly than smaller stars due to the principle of conservation of angular momentum. As stars like VY Canis Majoris expand during their later stages of evolution, their rotation rate decreases. This occurs because the star's mass is spread over a much larger volume, causing it to spin more slowly to maintain its angular momentum. Think of it like an ice skater extending their arms during a spin, causing them to slow down. The extreme size of VY Canis Majoris also means that its outer layers are only loosely bound by gravity. If it were to rotate too quickly, these outer layers would be flung off into space. The slow rotation helps the star maintain its tenuous grip on its outermost material. Interestingly, the reduced rotation rate of VY Canis Majoris affects other aspects of the star's behavior. It can lead to less mixing of elements within the star, influencing its internal chemistry and the processes that drive its enormous energy output. This interplay between size, rotation, and stellar physics makes VY Canis Majoris a captivating subject for astronomers studying the extremes of stellar evolution. VY Canis Majoris, one of the largest known stars in our galaxy, is a fascinating subject for astronomers and space enthusiasts alike. This hypergiant star, located in the constellation Canis Major, is nearing the end of its stellar life. Scientists estimate that VY Canis Majoris is approximately 8 to 9 million years old. This might seem like an incredibly long time from a human perspective, but in cosmic terms, it's relatively short. For comparison, our Sun is about 4.5 billion years old and is only halfway through its lifespan. The future of VY Canis Majoris is a subject of intense study. Given its enormous mass and high rate of mass loss, astronomers predict that this stellar giant will likely exhaust its nuclear fuel within the next 100,000 to 1 million years. When this happens, the star will end its life in a spectacular supernova explosion, briefly outshining entire galaxies before collapsing into a black hole. This relatively short lifespan is typical for supermassive stars like VY Canis Majoris. The more massive a star is, the faster it burns through its fuel, leading to a shorter overall existence. The immense size and luminosity of VY Canis Majoris come at the cost of a brief cosmic life, but one that will undoubtedly leave a lasting impact on its galactic neighborhood. VY Canis Majoris, one of the largest known stars in our galaxy, maintains its colossal size through a delicate balance of forces. At its core, nuclear fusion generates an immense amount of energy, creating outward pressure that counteracts the inward pull of gravity. This process, known as hydrostatic equilibrium, is common to all stars but operates on an extreme scale in VY Canis Majoris. The star's enormous mass, estimated to be around 40 times that of our Sun, produces a powerful gravitational field. However, its extremely low density, far less than that of Earth's atmosphere, allows it to exist in a highly expanded state. This low density is a result of the star's late evolutionary stage, where it has swollen to become a red hypergiant. Radiation pressure also plays a crucial role in maintaining the star's size. The intense light and heat generated in the core exert an outward force on the star's outer layers, further counteracting gravity's pull. This radiation pressure is so strong that it drives powerful stellar winds, causing VY Canis Majoris to lose mass at a rapid rate. Despite this equilibrium, VY Canis Majoris is in a constant state of change. Its size fluctuates as internal processes shift, and it continues to lose mass through its stellar winds. Eventually, the star will exhaust its fuel, leading to a dramatic end for this cosmic giant. Until then, it remains a testament to the extraordinary forces at play in the universe. VY Canis Majoris is a stellar behemoth that dwarfs our Sun in both size and brightness. This hypergiant star outshines our local star by an astounding factor of around 270,000 times. To put this in perspective, if we were to replace our Sun with VY Canis Majoris, its surface would extend beyond the orbit of Jupiter, engulfing everything in its path. The immense luminosity of VY Canis Majoris stems from its colossal size and extreme temperature. While our Sun fuses hydrogen in its core, VY Canis Majoris has exhausted its central hydrogen supply and now burns heavier elements, releasing enormous amounts of energy in the process. This energy radiates outward, resulting in its tremendous brightness. However, this extraordinary luminosity comes at a cost. VY Canis Majoris is rapidly consuming its fuel and ejecting vast amounts of material into space. In cosmic terms, it is nearing the end of its life, and astronomers predict it will eventually explode as a supernova, briefly outshining entire galaxies before fading away. VY Canis Majoris, one of the largest known stars in our galaxy, exerts an immense influence on the fabric of space-time around it. This hypergiant star, with a mass estimated to be around 40 times that of our Sun, creates a profound gravitational well in its vicinity. The sheer mass of VY Canis Majoris causes space-time to curve dramatically in its presence. This curvature is so significant that it noticeably alters the path of light passing near the star. Light from distant objects behind VY Canis Majoris would appear bent or distorted to an observer, a phenomenon known as gravitational lensing. The star's extreme mass also affects the flow of time in its vicinity. Time moves more slowly in stronger gravitational fields, a concept known as gravitational time dilation. Near the surface of VY Canis Majoris, time would pass more slowly compared to regions farther away from the star. This time dilation effect, while small, would be measurable and more pronounced than around smaller stars. If VY Canis Majoris were to collapse into a black hole at the end of its life, the space-time distortion would become even more extreme. The immense gravity would create an event horizon, a boundary beyond which nothing, not even light, could escape the black hole's gravitational pull. This would represent one of the most extreme warping of space-time possible in the universe. VY Canis Majoris, one of the largest known stars in our galaxy, is currently in the late stages of its stellar evolution. This enormous red hypergiant star has already moved beyond the main sequence phase of its life and is now approaching the end of its stellar journey. As a red hypergiant, VY Canis Majoris has exhausted the hydrogen fuel in its core and has expanded to an immense size. Its outer layers have cooled and reddened, giving it its characteristic appearance. The star is now fusing heavier elements in its core, a process that will continue until it can no longer sustain fusion reactions. Given its extreme mass, VY Canis Majoris is expected to end its life in a spectacular supernova explosion. However, the exact timing of this event is uncertain. It could occur within the next 100,000 years, or perhaps even sooner. The star is currently experiencing significant mass loss through powerful stellar winds, shedding material into space and forming a complex nebula around itself. This phase of stellar evolution is relatively short-lived compared to a star's overall lifespan, making VY Canis Majoris a rare and valuable object of study for astronomers. Its eventual supernova will likely leave behind a black hole, contributing to the ongoing cycle of stellar life and death in our universe. VY Canis Majoris, one of the largest known stars in our galaxy, began its life in a massive molecular cloud. These clouds, composed primarily of hydrogen and helium, are the birthplaces of stars. In the case of VY Canis Majoris, The cloud contained an exceptionally large amount of material. Gravitational forces caused a portion of this cloud to collapse inward, growing denser and hotter over time. As the temperature and pressure at the core increased, nuclear fusion ignited, marking the birth of the star. Due to its enormous initial mass, Canis Majoris quickly became a supergiant, bypassing the main sequence stage that most stars experience. The formation of such a massive star is a rare event, occurring only in regions with abundant gas and dust. These conditions were present in the spiral arm of the Milky Way, where Canis Majoris formed, approximately 8 to 9 million years ago. As the star evolved, it entered a phase of extreme mass loss, shedding vast amounts of material into space. This process continues today, shaping both the star and its surrounding environment, and contributing to the complex structures observed around Canis Majoris. Canis Majoris, one of the largest known stars in our galaxy, began its stellar journey as a massive O-type star. These stars are born with an incredible amount of mass, typically more than 20 times that of our Sun. O-type stars are among the hottest and most luminous stars in the universe, burning through their fuel at an astonishing rate. As Canis Majoris aged, it evolved off the main sequence, where stars spend most of their lives fusing hydrogen into helium in their cores. The star then entered a phase of rapid expansion and cooling, transforming into a red supergiant. This stage marked a significant increase in its size, though not yet to the extreme proportions we observe today. The transition from red supergiant to hypergiant occurred as Canis Majoris continued to evolve. During this process, the star experienced intense mass loss through powerful stellar winds, shedding vast amounts of material into space. This mass loss, combined with internal changes in the star's structure, led to its classification as a hypergiant. Now, as a yellow hypergiant, Canis Majoris exists in a rare and short-lived phase of stellar evolution. It continues to lose mass at a tremendous rate, shaping the surrounding space with its powerful outflows and preparing for the next stage in its cosmic life cycle. Canis Majoris, one of the largest known stars in our galaxy, has undergone significant changes in size throughout its lifetime. This behemoth star began its life as a massive, hot blue star, already considerably larger than our Sun. However, its true expansion occurred as it entered the later stages of stellar evolution. As Canis Majoris aged, it exhausted the hydrogen fuel in its core and began fusing heavier elements. This process caused the star to swell dramatically, transforming it into a red hypergiant. Its radius expanded to nearly 1,500 times that of our Sun, reaching a size that would extend beyond the orbit of Jupiter if placed at the center of our solar system. Interestingly, recent observations suggest that Canis Majoris might have actually decreased in size over the past few decades. This reduction could be due to mass loss through powerful stellar winds or changes in its internal structure. Despite this potential shrinkage, it remains one of the largest stars we know of, with a radius still exceeding 1,000 times that of our Sun. The future of Canis Majoris will likely involve further changes in size. As it continues to evolve, it may experience additional expansion and contraction cycles before ultimately ending its life in a spectacular supernova explosion, temporarily outshining entire galaxies. Canis Majoris, one of the largest known stars in our galaxy, faces a dramatic and explosive end. This hypergiant star, with a mass estimated at around 40 times that of our Sun, is already in the late stages of its stellar life. As it continues to burn through its nuclear fuel at an astounding rate, it grows increasingly unstable. The fate of Canis Majoris is inextricably linked to its enormous size. When it exhausts its nuclear fuel, the star's core will collapse under its own immense gravity. This collapse will trigger a spectacular supernova explosion, briefly outshining entire galaxies. The intense energy released during this event will forge heavy elements and scatter them across space, enriching the cosmos with the building blocks for future stars and planets. After the supernova, the remnant core of Canis Majoris will likely become a black hole. Given its exceptional mass, the resulting black hole could be significantly larger than those typically formed from less massive stars. This black hole will continue to influence its surroundings through its intense gravitational pull, potentially capturing nearby gas and dust in an accretion disk. The demise of VY Canis Majoris serves as a cosmic reminder of the life cycle of stars and the dynamic nature of our universe. Its end will mark the beginning of new stellar stories, as the materials it disperses become part of the next generation of celestial objects. VY Canis Majoris, one of the largest known stars in our galaxy, follows a dramatically different evolutionary path compared to smaller stars like our Sun. This hypergiant star began its life with an enormous mass, at least 40 times that of our Sun. This immense size significantly accelerates its life cycle and alters its fate. Unlike smaller stars that can sustain hydrogen fusion in their cores for billions of years, VY Canis Majoris burns through its fuel at an astonishing rate. Its tremendous gravity causes its core to be much hotter and denser, leading to faster fusion reactions. As a result, VY Canis Majoris will exhaust its hydrogen fuel in just a few million years, a mere blink of an eye in cosmic terms. As VY Canis Majoris ages, it expands to become a red hypergiant, growing to a size that could engulf the orbit of Jupiter if placed in our solar system. During this phase, it experiences intense mass loss through powerful stellar winds, shedding vast amounts of material into space. This mass loss is far more extreme than what smaller stars experience. The final fate of VY Canis Majoris will also be more spectacular than that of smaller stars. While stars like our Sun end their lives as white dwarfs, VY Canis Majoris is destined for a more dramatic conclusion. It will likely explode as a supernova, briefly outshining entire galaxies before collapsing into a black hole. This stark difference in evolutionary paths showcases the diverse life cycles of stars in our universe. VY Canis Majoris offers astronomers a unique window into the later stages of stellar evolution, particularly for massive stars. This hypergiant star, one of the largest known in our galaxy, demonstrates the extreme conditions that exist when a star approaches the end of its life. Studying VY Canis Majoris reveals crucial information about mass loss in massive stars. As these giants burn through their fuel, they shed enormous amounts of material into space. This process significantly impacts their evolution and ultimate fate. By observing the extensive nebula surrounding VY Canis Majoris, scientists can better understand how this mass loss occurs and how it shapes the star's environment. The star's immense size and luminosity also provide insights into the physical limits of stellar structure. VY Canis Majoris challenges our models of stellar evolution, pushing the boundaries of what we thought possible for a star's mass and radius. This forces astrophysicists to refine their theories and computational models, advancing our overall understanding of stellar physics. Furthermore, the fate of VY Canis Majoris offers clues about the final stages of massive stars. While its exact future remains uncertain, studying this star helps scientists predict whether it will explode as a supernova or collapse directly into a black hole. This knowledge is crucial for understanding the life cycles of stars and the processes that create heavy elements in the universe. VY Canis Majoris, one of the largest known stars in our galaxy, is a hypergiant star nearing the end of its life. This colossal celestial body is expected to remain in its current state for a relatively short period on cosmic timescales. Astronomers estimate that VY Canis Majoris might continue in its present form for only about 100,000 to 500,000 years more. This timeframe is remarkably brief compared to the typical lifespan of stars, which can range from millions to billions of years. The rapid evolution of VY Canis Majoris is due to its enormous mass and the intense nuclear reactions occurring in its core. These factors cause the star to burn through its fuel at an accelerated rate, hastening its journey towards its final stages. As VY Canis Majoris continues to evolve, it will experience significant changes. The star is already losing mass at a tremendous rate, expelling vast amounts of material into space through powerful stellar winds. This process will intensify as the star approaches the end of its life, dramatically altering its structure and appearance. The fate of VY Canis Majoris after this period remains a subject of scientific interest. Given its extreme mass, many astronomers believe it will ultimately explode as a supernova, briefly outshining entire galaxies before collapsing into a black hole. This spectacular event will mark the end of one of the most remarkable stars known to science, transforming the region of space it once dominated. VY Canis Majoris, one of the largest known stars in our galaxy, is already in the late stages of its stellar evolution. As this hypergiant star approaches the end of its life, it will undergo several dramatic changes. The star will continue to expand, potentially reaching a size that could engulf the orbit of Jupiter if it were placed in our solar system. This expansion is accompanied by significant mass loss, with VY Canis Majoris shedding vast amounts of material into space, creating a complex nebula around itself. As its fuel depletes, the star will experience periods of intense pulsation and instability. These pulsations will cause the star to brighten and dim irregularly, while also triggering more extreme episodes of mass loss. The ejected material will form shells and arcs around the star, contributing to the intricate structure of its surrounding nebula. Given its enormous mass, VY Canis Majoris is likely to end its life in a spectacular supernova explosion. However, there is also a possibility that it might collapse directly into a black hole without a visible supernova, a process called failed supernova. Either outcome will have a profound impact on its surrounding environment, enriching the interstellar medium with heavy elements and potentially triggering the formation of new stars. VY Canis Majoris, one of the largest known stars in our galaxy, exhibits an extraordinary mass loss rate that far surpasses that of most other stars. This red hypergiant sheds an astonishing amount of material into space, estimated at around 30 times the mass of Earth each year. To put this in perspective, our Sun loses roughly 100 million times less mass annually. This extreme mass loss is a result of VY Canis Majoris's enormous size and unstable nature. Its tenuous outer layers are only loosely bound by gravity, allowing stellar winds and periodic outbursts to easily strip away vast quantities of gas and dust. These ejected materials form an extensive, complex nebula surrounding the star. Compared to other massive stars, VY Canis Majoris still stands out. Even among its fellow red supergiants, its mass loss rate is exceptional. For instance, Betelgeuse, another well-known red supergiant, loses mass at a rate about 10 times lower than VY Canis Majoris. This difference highlights the unique and extreme nature of VY Canis Majoris in the stellar population. The rapid mass loss of VY Canis Majoris provides astronomers with a valuable opportunity to study the late stages of stellar evolution in very massive stars. As it sheds its outer layers, the star is essentially giving us a preview of the processes that will eventually lead to its demise as a supernova, offering crucial insights into the life cycles of the universe's most massive stellar objects. VY Canis Majoris, one of the largest known stars in our galaxy, boasts an atmosphere that is as extraordinary as its size. This hypergiant star's outer layers are primarily composed of hydrogen and helium, the two most abundant elements in the universe. However, it is the presence of other elements and compounds that makes its atmosphere truly fascinating. The star's immense size and low surface gravity allow for an extended atmosphere rich in various molecules. Observations have revealed significant amounts of oxygen, sulfur, and nitrogen compounds. Water vapor has been detected in surprising quantities, along with silicon oxide and aluminum oxide. These compounds form intricate dust grains that scatter light and contribute to the star's distinctive reddish hue. Perhaps most intriguing is the presence of titanium oxide in VY Canis Majoris's atmosphere. This compound, rarely found in such abundance in stellar atmospheres, plays a crucial role in the star's appearance and behavior. The titanium oxide absorbs certain wavelengths of light, further enhancing the star's deep red color and affecting its overall brightness. The dynamic nature of VY Canis Majoris's atmosphere is evident in its constant state of outflow. As the star sheds mass at an astonishing rate, it enriches the surrounding interstellar medium with these diverse elements and compounds, contributing to the cosmic cycle of stellar evolution and elemental distribution throughout the galaxy. The atmosphere of VY Canis Majoris is a stark contrast to that of our Sun, showcasing the extreme diversity found in stellar environments. This hypergiant star, one of the largest known in the universe, boasts an atmosphere that extends far beyond its already enormous radius. Unlike our Sun's relatively compact atmosphere, VY Canis Majoris has an extensive, diffuse envelope of gas that stretches out to incredible distances. This expansive atmosphere is much cooler than the Sun's, with temperatures ranging from about 2,000 to 3,000 Kelvin compared to the Sun's corona, which can reach millions of degrees. The chemical composition of VY Canis Majoris's atmosphere also differs significantly. It contains a rich variety of molecules and dust, including compounds like titanium oxide, silicon oxide, and various metals. These materials form in the cooler outer layers and are often ejected into space, creating a vast nebula around the star. In contrast, our Sun's hotter atmosphere is primarily composed of ionized hydrogen and helium. Perhaps the most striking difference is the dynamic nature of VY Canis Majoris's atmosphere. It undergoes massive eruptions and ejections, expelling enormous amounts of material into space at a rate thousands of times greater than our Sun's solar wind. This intense mass loss shapes the star's surroundings and contributes to its eventual fate, a stark reminder of the powerful forces at work in the cosmos. VY Canis Majoris, one of the largest known stars in our galaxy, has revealed some intriguing elements in its spectrum. Astronomers have detected significant amounts of sulfur compounds in the atmosphere of this hypergiant star, which is quite unusual for a star of its type. These sulfur-bearing molecules, including sulfur dioxide and silicon disulfide, are more commonly associated with volcanic activity on planets rather than stellar atmospheres. Another surprising discovery in VY Canis Majoris's spectrum is the presence of water vapor. While water is abundant in the universe, finding it in the spectrum of such a massive and hot star was unexpected. This water vapor likely exists in a cooler, outer layer of the star's extended atmosphere. The spectrum also shows evidence of heavy elements like titanium and scandium. These elements are produced through nuclear fusion in the cores of massive stars, and their presence in the outer layers suggests that VY Canis Majoris has undergone significant internal mixing processes during its lifetime. These unusual spectral features provide valuable insights into the complex chemistry and dynamics occurring in the atmospheres of hypergiant stars. They also offer clues about the late stages of stellar evolution for these cosmic behemoths, helping astronomers better understand the life cycles of the most massive stars in our universe. VY Canis Majoris, one of the largest known stars in our galaxy, exhibits extraordinary atmospheric properties due to its immense size. This hypergiant star is so vast that if placed at the center of our solar system, its surface would extend beyond the orbit of Jupiter. The sheer scale of VY Canis Majoris creates an atmosphere that defies conventional stellar models. Its outer layers are so tenuous and spread out that they barely cling to the star, resulting in significant mass loss through powerful stellar winds. These winds are far more intense than those of smaller stars, ejecting material at rates up to several thousand times greater than our Sun. The extreme size also affects the star's temperature distribution. While smaller stars have a clear boundary between their surface and atmosphere, VY Canis Majoris has a much more gradual transition. This creates an extended, cooler, outer region where complex molecules can form, something rarely seen in other stars. Furthermore, the enormous gravity of VY Canis Majoris struggles to maintain the star's spherical shape against its own radiation pressure. This results in an unstable, pulsating atmosphere with massive convection cells that dwarf the size of entire planets, causing visible irregularities and asymmetries in the star's appearance. Stellar winds play a crucial role in shaping the atmosphere of VY Canis Majoris, one of the largest known stars in our galaxy. These powerful outflows of gas and dust are driven by the intense radiation pressure from the star's incredibly luminous core. In the case of VY Canis Majoris, a red hypergiant, these winds are particularly strong and have a profound impact on its structure and evolution. The stellar winds of VY Canis Majoris are so intense that they cause the star to lose mass at an astonishing rate, estimated to be about 30 times the mass of Earth each year. This tremendous mass loss creates an extended, complex atmosphere around the star, forming a vast, nebulous envelope that stretches far into space. As these winds interact with the surrounding interstellar medium, they create intricate patterns and structures in the star's outer layers. Observations have revealed arcs, knots, and filaments in the extended atmosphere, suggesting a history of episodic mass loss events and complex wind dynamics. These features provide valuable insights into the star's past and current state. The stellar winds also contribute to the star's instability and variability. As material is continuously ejected from the surface, it affects the star's overall structure and energy balance. This process is a key factor in the star's eventual fate, as the ongoing mass loss will ultimately lead to the final stages of its stellar evolution, potentially culminating in a supernova explosion. The atmosphere of VY Canis Majoris plays a crucial role in shaping its striking appearance. This hypergiant star, one of the largest known in the universe, boasts an atmosphere that extends far beyond its already enormous radius. The star's outer layers are incredibly tenuous and cool compared to its blazing core. This extended atmosphere is composed primarily of hydrogen and helium, with traces of heavier elements. As light from the star's interior passes through this vast atmospheric envelope, it undergoes complex interactions that contribute to the star's distinctive reddish hue. Dust particles in the outer regions of the atmosphere scatter and absorb certain wavelengths of light, further enhancing the star's ruddy appearance. This dust, along with gases ejected by the star, forms an extensive circumstellar envelope that can span hundreds of times the star's radius. This envelope is not uniform but contains clumps, arcs, and filaments that create a mottled, irregular appearance when observed through powerful telescopes. The dynamic nature of VY Canis Majoris's atmosphere also contributes to its changing brightness. As the star pulsates and ejects material, its apparent magnitude can vary over time, adding to its enigmatic character and making it a fascinating subject for astronomers studying the life cycles of massive stars. VY Canis Majoris, one of the largest known stars in our galaxy, presents a stark contrast between its atmosphere and core. The atmosphere of this red hypergiant star is incredibly diffuse, with a density so low it would be considered a near vacuum on Earth. In fact, the outer layers of VY Canis Majoris are so tenuous that they are more comparable to the density of Earth's upper atmosphere than anything we typically associate with a star. In sharp contrast, the core of VY Canis Majoris is incredibly dense. As we move inward from the diffuse outer layers, the density increases dramatically due to the immense gravitational forces at work. The core, where nuclear fusion takes place, is compressed to densities millions of times greater than the star's atmosphere. This extreme density difference highlights the complex structure of massive stars. The core's density allows it to sustain the nuclear reactions that power the star, while the expansive, low-density atmosphere is a result of the star's enormous size and the outward pressure of radiation from these nuclear reactions. Understanding this density contrast not only gives us insight into the structure of VY Canis Majoris, but also helps explain its behavior, including its high mass loss rate and the eventual fate that awaits this cosmic behemoth. VY Canis Majoris, one of the largest known stars in our galaxy, exhibits atmospheric conditions that are truly extraordinary. The atmospheric pressure of this hypergiant star is remarkably low compared to most other stars, including our Sun. This is primarily due to its enormous size and relatively low density. The atmosphere of VY Canis Majoris extends far beyond what we typically see in smaller stars. Its outer layers are so vast and diffuse that the pressure at its visible surface is significantly lower than that of the Sun. In fact, the density of the outer regions of VY Canis Majoris is more akin to a very thin gas than what we might typically consider stellar material. This low atmospheric pressure is a direct result of the star's immense size and mass. The gravitational pull at the surface is spread over a much larger area, resulting in a weaker force per unit area. Consequently, the star's atmosphere is less compressed and more expansive than that of smaller, more compact stars. The unique atmospheric conditions of VY Canis Majoris have important implications for its evolution and eventual fate. As the star continues to expand and lose mass through powerful stellar winds, its already tenuous atmosphere becomes even more diffuse, ultimately contributing to the star's eventual demise as a supernova. VY Canis Majoris, one of the largest known stars in our galaxy, offers a fascinating glimpse into stellar evolution. The composition of this hypergiant star reveals a complex history of nuclear fusion and mixing processes that have occurred over millions of years. Analysis of VY Canis Majoris shows an abundance of heavy elements in its outer layers, including carbon, oxygen, and nitrogen. These elements are typically produced in the cores of massive stars through various fusion reactions. Their presence in the star's atmosphere indicates that VY Canis Majoris has undergone significant internal mixing, bringing material from its core to its surface. The star's composition also shows evidence of mass loss, with a surrounding nebula rich in dust and molecules. This suggests that VY Canis Majoris has been shedding its outer layers for an extended period, a characteristic behavior of stars nearing the end of their lives. The presence of certain isotopes in this ejected material provides clues about the nuclear reactions occurring within the star. Furthermore, the ratio of different elements in VY Canis Majoris can tell us about its initial mass and the conditions under which it formed. By studying these compositional details, astronomers can piece together the life story of this enormous star, from its birth in a molecular cloud to its current state as a highly evolved hypergiant on the brink of its final transformation. The atmosphere of VY Canis Majoris plays a crucial role in its extraordinary luminosity. This red hypergiant star, one of the largest known stars in our galaxy, has an extended and complex atmosphere that significantly influences how we perceive its brightness. The outer layers of VY Canis Majoris are incredibly diffuse and extend far beyond what we would typically consider the star's surface. This expansive atmosphere is composed of various elements and compounds, including dust particles and molecular gases. These materials interact with the intense radiation pouring out from the star's core, scattering and absorbing light in complex ways. Interestingly, the star's atmosphere is not uniform. It contains regions of varying density, temperature, and composition. These irregularities create pockets where light can escape more easily, while other areas might obscure or redden the star's output. This dynamic interplay between the star's radiation and its atmospheric components results in the star's observed luminosity fluctuating over time. Moreover, the immense size of VY Canis Majoris means that its atmosphere is constantly in motion, with massive convection cells carrying energy from the interior to the surface. This process, combined with the star's intense stellar winds, leads to the ejection of material into space, forming a surrounding nebula. This nebula further interacts with the star's light, contributing to its overall observed luminosity and making VY Canis Majoris a fascinating subject for astronomers studying stellar evolution and the behavior of hypergiant stars. Amateur astronomers can observe VY Canis Majoris with some effort and the right equipment. This hypergiant star, one of the largest known stars in our galaxy, is located in the constellation Canis Major. While it's not visible to the naked eye, it can be spotted using a medium-sized telescope under good viewing conditions. To find VY Canis Majoris, observers should first locate the constellation Canis Major, which is visible from both hemispheres during winter months. The star Sirius, the brightest star in the night sky, serves as a helpful reference point within this constellation. VY Canis Majoris lies about 7.5 degrees northwest of Sirius. A telescope with an aperture of at least 8 inches is recommended for observing this distant star. Due to its extreme distance of approximately 3,900 light-years from Earth, VY Canis Majoris will appear as a faint reddish point of light. Patience and dark skies are crucial for a successful observation. For those interested in astrophotography, capturing images of VY Canis Majoris requires long exposure times and specialized equipment. While challenging, photographing this enormous star can be a rewarding experience for dedicated amateur astronomers, offering a glimpse of one of the universe's most extraordinary objects. Several powerful telescopes have been instrumental in studying the enormous hypergiant star VY Canis Majoris. The Hubble Space Telescope has played a crucial role, capturing high-resolution images that reveal the complex structure of the star's surrounding nebula. These observations have helped astronomers understand the intense mass loss and outflow processes occurring in this stellar behemoth. Ground-based observatories have also contributed significantly to our knowledge of VY Canis Majoris. The Very Large Telescope in Chile has used its advanced adaptive optics systems to peer through Earth's atmosphere and observe the star's outer layers. Additionally, the Keck Observatory in Hawaii has employed its large mirror and sophisticated instruments to analyze the chemical composition of the material ejected by the star. Radio telescopes have provided valuable insights into the cooler regions surrounding VY Canis Majoris. The Atacama Large Millimeter Array in Chile has detected various molecules in the star's extended atmosphere, helping scientists understand the complex chemistry occurring in these extreme environments. The Very Large Array in New Mexico has also been used to study the radio emissions from the star and its surroundings, providing information about its magnetic fields and dust content. Infrared telescopes like the Spitzer Space Telescope have been crucial in studying the dust produced by VY Canis Majoris. These observations have helped astronomers estimate the total mass lost by the star over time and better understand its evolutionary stage. The combined efforts of these diverse telescopes have given us a comprehensive view of this extraordinary star from its core to its extended nebula. Our understanding of VY Canis Majoris has evolved significantly with advancements in observational techniques. Initially thought to be one of the largest known stars in the universe, recent studies have refined our perception of this celestial giant. Early observations using visible light telescopes suggested that VY Canis Majoris was an extraordinarily massive hypergiant star, potentially up to 3,000 times the size of our Sun. However, more sophisticated instruments and methods have led to a reassessment of its dimensions. Infrared observations and interferometry have allowed astronomers to peer through the dense envelope of material surrounding the star, providing a clearer picture of its true size. These techniques revealed that while VY Canis Majoris is indeed enormous, it is smaller than previously estimated, with a radius closer to 1,400 times that of the Sun. Despite this downward revision in size, VY Canis Majoris remains one of the most intriguing objects in our galaxy. Its extreme luminosity and the complex structures of gas and dust surrounding it continue to captivate researchers, offering valuable insights into the late stages of stellar evolution for very massive stars. Observing VY Canis Majoris presents several unique challenges for astronomers. This hypergiant star, one of the largest known stars in our galaxy, is shrouded in a dense envelope of dust and gas, obscuring direct observation of its surface. This veil of material not only blocks visible light, but also distorts and scatters the star's emissions, making it difficult to accurately measure its size and physical properties. The sheer distance to VY Canis Majoris, approximately 3,900 light-years from Earth, further complicates observations. At this vast distance, even our most powerful telescopes struggle to resolve fine details of the star and its surrounding environment. The star's remote location also means that the light we observe today left the star nearly 4,000 years ago, adding another layer of complexity to understanding its current state. Another significant challenge lies in VY Canis Majoris's dynamic nature. As a highly evolved star nearing the end of its life, it undergoes rapid and unpredictable changes. These include massive outbursts of material and fluctuations in brightness, which can occur on timescales ranging from months to years. This variability makes it challenging for astronomers to obtain consistent and reliable data over extended periods. Lastly, the extreme nature of VY Canis Majoris pushes the limits of our current stellar models. Its enormous size and mass place it at the edge of theoretical predictions for stellar structure and evolution. This means that astronomers must constantly refine and update their models to account for the unusual characteristics observed in this cosmic behemoth, making VY Canis Majoris a crucial test case for our understanding of stellar physics at the most extreme scales. The immense distance of VY Canis Majoris presents significant challenges for astronomers seeking to study this colossal star. Located approximately 3,900 light-years from Earth, this red hypergiant resides in the constellation Canis Major. Its vast separation from our planet means that the light we observe today left the star nearly 4,000 years ago, complicating our understanding of its current state. This enormous distance impacts our ability to gather detailed information about VY Canis Majoris in several ways. Firstly, it limits the resolution of images we can obtain. Even with our most advanced telescopes, the star appears as a point of light rather than a discernible disk, making it difficult to directly measure its size or observe surface features. Furthermore, the distance affects the accuracy of our measurements. Determining precise values for the star's mass, radius, and temperature becomes more challenging as distance increases. Astronomers must rely on indirect methods and complex calculations to estimate these properties, introducing potential uncertainties in their findings. Despite these obstacles, modern technology and innovative observational techniques have allowed scientists to glean valuable insights about VY Canis Majoris. By studying its spectrum, infrared emissions, and surrounding dust clouds, researchers continue to unravel the mysteries of this extraordinary stellar giant, pushing the boundaries of our understanding of massive stars and their life cycles. To study the enormous hypergiant star VY Canis Majoris, astronomers rely on a range of light wavelengths, each revealing different aspects of this celestial behemoth. Infrared light proves particularly valuable as it penetrates the dense clouds of dust surrounding the star, allowing scientists to peer into its cooler outer layers. These infrared observations help reveal the star's true size and structure. Visible light also plays a role, though much of it is obscured by the surrounding dust. The visible spectrum can provide information about the star's temperature and composition when combined with other data. Radio waves are crucial for studying the vast clouds of gas expelled by VY Canis Majoris, offering insights into its mass loss and stellar wind processes. X-rays, while less prominent, can indicate high-energy processes occurring in the star's atmosphere. Ultraviolet light, though mostly absorbed by interstellar dust, can still offer valuable data about the star's hottest regions when detected by space-based telescopes. By combining observations from these different wavelengths, astronomers can build a comprehensive picture of VY Canis Majoris, from its enormous size to its dynamic behavior and eventual fate. This multi-wavelength approach is essential for understanding such extreme and rare stars in our galaxy. Measuring the size of VY Canis Majoris presents a significant challenge for astronomers due to its immense distance from Earth and its complex, evolving nature. To determine its dimensions, scientists employ a combination of advanced techniques and powerful instruments. One primary method involves using interferometry, which combines light from multiple telescopes to create a single, highly detailed image. This technique allows astronomers to resolve the star's apparent size in the sky with unprecedented precision. The Very Large Telescope Interferometer in Chile has been particularly useful in these observations, providing crucial data on VY Canis Majoris. Spectroscopic analysis also plays a vital role in size estimation. By studying the star's spectrum, astronomers can determine its temperature and luminosity. These properties, combined with our understanding of stellar physics, allow scientists to calculate the star's radius. Additionally, observations of the star's photosphere and surrounding dust envelope help refine these measurements. It is important to note that VY Canis Majoris is not a static object. As a red hypergiant, it is constantly changing, with an irregular, pulsating outer layer. This dynamic nature means that its size can vary over time, adding another layer of complexity to the measurement process. Despite these challenges, ongoing observations and improving technologies continue to refine our understanding of this cosmic behemoth. The Hubble Space Telescope has been instrumental in our study of VY Canis Majoris, one of the largest known stars in the universe. This powerful space-based observatory has provided astronomers with unprecedented views of this hypergiant star, revealing crucial details about its size, composition, and behavior. Hubble's high-resolution imaging capabilities have allowed scientists to observe the complex structure surrounding VY Canis Majoris. These observations have shown that the star is surrounded by an extensive, asymmetric nebula of gas and dust ejected by the star over thousands of years. This material forms intricate arcs, knots, and filaments, extending far into space. The telescope's spectrographs have also been vital in analyzing the chemical composition of VY Canis Majoris and its surrounding nebula. By studying the light emitted and absorbed by the star and its environment, astronomers have identified various elements and molecules present, providing insights into the star's evolutionary history and the processes occurring within it. Furthermore, Hubble's observations over time have helped scientists track changes in VY Canis Majoris, including variations in its brightness and the ongoing mass loss that characterizes its current stage of evolution. This long-term monitoring has been crucial in understanding the dynamic nature of hypergiant stars and their impact on their cosmic surroundings. Astronomers employ a powerful technique called spectroscopy to unravel the composition of VY Canis Majoris, one of the largest known stars in our galaxy. This method involves analyzing the light emitted by the star, which carries a wealth of information about its chemical makeup. When starlight is spread out into its component colors, it reveals a spectrum with dark lines where specific wavelengths are absorbed by elements in the star's atmosphere. Each element has a unique set of absorption lines, acting like a fingerprint that astronomers can identify. For VY Canis Majoris, these spectral lines indicate the presence of various elements such as hydrogen, helium, carbon, and heavier elements forged in previous generations of stars. The strength and width of these spectral lines provide crucial details about the star's temperature, density, and the abundance of different elements. In the case of VY Canis Majoris, astronomers have detected signatures of molecules like water vapor, silicon oxide, and titanium oxide in its extended atmosphere, indicating a complex chemical environment. Advanced telescopes and spectrographs, both on Earth and in space, allow astronomers to capture high-resolution spectra of VY Canis Majoris. By comparing these observations with laboratory measurements and theoretical models, scientists can build a comprehensive picture of the star's composition, shedding light on its evolutionary history and the processes occurring in its vast, turbulent atmosphere. Future observational missions could significantly enhance our knowledge of VY Canis Majoris, one of the largest known stars in the universe. Advanced space telescopes with improved infrared capabilities would allow astronomers to peer through the dense dust surrounding this hypergiant star, revealing more details about its structure and composition. A next-generation interferometer in space could provide unprecedented resolution, enabling scientists to map the star's surface features and study its massive outflows in greater detail. This technology would help us better understand the complex processes driving VY Canis Majoris's extreme mass loss and evolution. Missions focused on high-resolution spectroscopy could offer insights into the star's chemical makeup and internal dynamics. By analyzing the light from different layers of the star's atmosphere, researchers could gain a clearer picture of its internal structure and the mechanisms behind its enormous size. Long-term monitoring missions would be particularly valuable, allowing astronomers to track changes in VY Canis Majoris over time. This data could help predict the star's future behavior and provide crucial information about the late stages of stellar evolution for these rare, massive stars. VY Canis Majoris, one of the largest known stars in our galaxy, has not been confirmed to have any planetary companions. This red hypergiant star, located approximately 3,900 light-years from Earth in the constellation Canis Major, presents unique challenges for planetary detection. The sheer size and instability of VY Canis Majoris make it an unlikely host for planets. Its radius is estimated to be around 1,400 times that of our Sun, and if placed at the center of our solar system, its surface would extend beyond the orbit of Jupiter. The star is also losing mass at a rapid rate, expelling vast amounts of material into space and creating a complex, dusty environment around it. These characteristics make traditional planet hunting methods, such as transit observations or radial velocity measurements, extremely difficult to apply. The intense stellar wind and variable nature of the star would likely mask any subtle signs of orbiting planets. Furthermore, the extreme conditions near VY Canis Majoris would be hostile to planet formation and survival. The intense radiation and gravitational forces would likely disrupt or destroy any planets that might have formed during earlier stages of the star's life. While the absence of detected planets does not conclusively rule out their existence, the current understanding of stellar and planetary physics suggests that VY Canis Majoris is an improbable candidate for hosting planetary companions. VY Canis Majoris, one of the largest known stars in our galaxy, exerts a powerful influence on its surrounding environment. This hypergiant star, located approximately 4,000 light-years from Earth, interacts with nearby interstellar gas and dust in several significant ways. The intense radiation from VY Canis Majoris ionizes and heats the surrounding gas, creating a vast, glowing nebula. This process, known as photoionization, strips electrons from atoms in the nearby interstellar medium, causing the gas to emit light across various wavelengths. The result is a spectacular display of color and luminosity that extends far beyond the star itself. Moreover, VY Canis Majoris is losing mass at an extraordinary rate through powerful stellar winds. These winds, composed of gas and dust particles, sweep outward from the star at velocities of up to 50 kilometers per second. As they collide with the surrounding interstellar medium, they create shock waves that compress and heat the gas, triggering the formation of complex molecular structures and potentially new stars. The star's immense gravitational pull also plays a role in shaping its environment. It attracts nearby gas and dust, creating a swirling accretion disk around itself. This process not only affects the distribution of matter in the vicinity, but also influences the star's own evolution, as some of this material may eventually be reabsorbed by VY Canis Majoris. VY Canis Majoris, one of the largest known stars in our galaxy, exerts a profound influence on its stellar neighborhood. This hypergiant star, with its enormous size and tremendous energy output, shapes the space around it in several significant ways. The intense stellar winds from VY Canis Majoris blast outward at incredible speeds, carrying vast amounts of material into the surrounding space. These winds sculpt the nearby interstellar medium, creating bubbles and cavities in the cosmic environment. As this material interacts with surrounding gas and dust, it can trigger the formation of new stars, effectively seeding the next generation of stellar objects. The extreme luminosity of VY Canis Majoris also affects its neighborhood. Its powerful radiation ionizes nearby gas clouds, creating glowing nebulae that can stretch for light years. This ionization process can both stimulate and inhibit star formation in the vicinity, depending on the distance and density of the surrounding material. Furthermore, the massive gravitational influence of VY Canis Majoris impacts the orbits of nearby stars and any potential planetary systems. Its presence can cause perturbations in these orbits, potentially leading to interesting dynamic interactions within its stellar community. As VY Canis Majoris approaches the end of its life, its eventual demise as a supernova will dramatically reshape its neighborhood, dispersing heavy elements crucial for future planet and star formation. VY Canis Majoris resides in a fascinating celestial neighborhood within the constellation Canis Major. Nearby, we find the brilliant star Sirius, the brightest star in our night sky. Sirius, though much smaller than VY Canis Majoris, outshines its giant neighbor due to its proximity to Earth. The region surrounding VY Canis Majoris is rich with stellar activity. It lies near the edge of a large molecular cloud complex known as the Canis Major OB1 Association. This area is a hotbed of star formation, containing numerous young, massive stars and stellar nurseries. Another notable object in the vicinity is the Open Star Cluster, NGC 2362. This cluster, visible to the naked eye under dark sky conditions, contains several hundred stars and provides a stunning contrast to the red supergiant VY Canis Majoris. The area also hosts several other red supergiants, though none as massive as VY Canis Majoris. These stars, along with numerous blue supergiants and Wolf-Rayet stars in the region, paint a diverse picture of stellar evolution and showcase the dynamic nature of our galaxy. VY Canis Majoris, one of the largest known stars in our galaxy, exerts a profound influence on its surrounding space environment through its intense radiation. This hypergiant star, with its enormous size and extreme luminosity, bathes its vicinity in a constant flood of energy across the electromagnetic spectrum. The star's radiation pressure is so powerful that it pushes away nearby gas and dust, creating a vast, relatively empty region around itself. This process, known as stellar wind, is far more intense for VY Canis Majoris than for smaller stars like our Sun. The stellar wind carries away significant amounts of the star's mass, enriching the surrounding interstellar medium with heavy elements forged in the star's core. The ultraviolet radiation from VY Canis Majoris ionizes nearby gas clouds, causing them to glow and creating spectacular nebulae. This ionization can trigger the formation of new stars in the surrounding molecular clouds as the radiation compresses the gas and initiates gravitational collapse. The extreme radiation also affects any potential planetary systems that might exist around nearby stars. It could strip away the atmospheres of gas giants and render rocky planets uninhabitable. However, this same radiation could potentially drive complex chemical reactions in the protoplanetary disks of forming star systems, influencing the composition of future planets. From a planet orbiting VY Canis Majoris, the night sky would be an awe-inspiring spectacle, unlike anything we experience on Earth. VY Canis Majoris is one of the largest known stars in the universe, a red hypergiant with a radius over 1,000 times that of our Sun. Its sheer size would dominate the sky, appearing not as a small point of light but as a massive, glowing orb. The star's reddish hue would bathe the planet in a constant, warm glow, casting long shadows and creating an otherworldly atmosphere. Even when the planet rotated away from the star, its immense size would ensure that a significant portion of the sky remained illuminated, potentially making true darkness a rare occurrence. Other stars would be visible, but their light would be diminished by the overwhelming brightness of VY Canis Majoris. The constellations familiar to us on Earth would be unrecognizable, rearranged from this new vantage point in the galaxy. Depending on the planet's location within the system, the view might include other celestial bodies such as gas giants or rocky worlds, adding to the visual splendor. Perhaps most striking would be the frequent stellar events visible from this hypothetical world. VY Canis Majoris is known for its intense stellar winds and occasional bright outbursts. Observers might witness spectacular eruptions with massive plumes of stellar material ejected into space, creating an ever-changing celestial display that would captivate any beings fortunate enough to behold it. VY Canis Majoris, one of the largest known stars in our galaxy, plays a significant role in shaping the Milky Way's structure and composition. This hypergiant star, located approximately 3,900 light-years from Earth, is a prime example of stellar extremes within our cosmic neighborhood. As a massive star, VY Canis Majoris exerts considerable gravitational influence on its surrounding space. Its immense gravity affects the movement and distribution of nearby gas and dust, potentially influencing the formation of new stars in its vicinity. This localized impact contributes to the overall dynamic nature of our galaxy's spiral arms, where most star formation occurs. Furthermore, VY Canis Majoris is in the late stages of its life, shedding enormous amounts of material into space. This process enriches the interstellar medium with heavy elements, which are essential for the formation of planets and the potential development of life. When this star eventually explodes as a supernova, it will release even more elements into the galaxy, further contributing to the Milky Way's chemical evolution. The study of stars like VY Canis Majoris helps astronomers understand the life cycles of massive stars and their impact on galactic evolution. By observing such extreme objects, scientists gain insights into the processes that shape our galaxy's structure, from its spiral arms to its chemical composition, ultimately piecing together the complex story of the Milky Way's past, present, and future. Stars like VY Canis Majoris, classified as red hypergiant stars, play a crucial role in galactic evolution. These massive stellar bodies, among the largest known stars in the universe, contribute significantly to the cosmic cycle of matter and energy. Throughout their lives, stars like VY Canis Majoris enrich their surroundings with heavy elements. They fuse lighter elements into heavier ones in their cores, creating a diverse array of chemical elements essential for the formation of planets, complex molecules, and even life itself. As these stars age, they expel vast amounts of material into space through powerful stellar winds, distributing these newly formed elements across their galactic neighborhoods. The ultimate fate of these hypergiant stars is equally impactful. When they exhaust their nuclear fuel, they end their lives in spectacular supernova explosions. These cosmic events release immense amounts of energy and disperse the star's remaining material across vast distances, further enriching the interstellar medium with heavy elements. This continuous cycle of stellar birth, evolution, and death drives the chemical evolution of galaxies. The material expelled by stars like VY Canis Majoris becomes the building blocks for new stars, planets, and potentially life-bearing worlds, shaping the composition and structure of entire galaxies over cosmic timescales. VY Canis Majoris, one of the largest known stars in our galaxy, exerts a powerful gravitational influence on its surroundings. This red hypergiant star, with a radius estimated to be over 1,000 times that of our Sun, creates a significant gravitational field that affects nearby celestial objects. The immense mass of VY Canis Majoris causes it to pull on neighboring stars, potentially altering their orbits and trajectories. Stars in close proximity may experience gravitational perturbations, leading to slight changes in their positions over time. This gravitational dance can result in complex interactions within star clusters or associations near VY Canis Majoris. Moreover, the star's enormous size and mass affect the distribution of interstellar gas and dust in its vicinity. The gravitational pull of VY Canis Majoris can compress nearby molecular clouds, potentially triggering the formation of new stars. This process, known as gravitational collapse, demonstrates how a single massive star can influence the birth of future stellar generations. It's important to note that the effects of VY Canis Majoris's gravity diminish with distance, following the inverse square law. While its influence is profound in its immediate neighborhood, stars at greater distances experience less gravitational interaction with this cosmic behemoth. The environment surrounding VY Canis Majoris offers a wealth of information about this colossal star's tumultuous past. As one of the largest known stars in our galaxy, VY Canis Majoris has been shaping its surroundings for millions of years through powerful stellar winds and intense radiation. Observations of the star's immediate vicinity reveal a complex nebula of gas and dust extending several light-years into space. This material, ejected from the star over time, forms intricate structures including arcs, knots, and filaments. The composition and distribution of this expelled matter provide crucial insights into the star's evolution and the processes occurring within its turbulent atmosphere. Spectroscopic analysis of the surrounding nebula indicates the presence of various elements and molecules, including silicates and water vapor. These chemical signatures help astronomers reconstruct the star's life story, offering clues about its initial mass, age, and the nuclear fusion reactions taking place in its core. The asymmetrical nature of the surrounding nebula suggests that VY Canis Majoris has undergone periods of intense and irregular mass loss. This erratic behavior is characteristic of hypergiant stars nearing the end of their lives, indicating that VY Canis Majoris may be approaching its final stages of stellar evolution. By studying this environment, scientists can better understand the life cycles of massive stars and the processes that will eventually lead to their spectacular demise as supernovae. VY Canis Majoris stands out as one of the most colossal stars known in our galaxy. This red hypergiant dwarfs many of its stellar counterparts, with a radius estimated to be around 1,500 times that of our Sun. If placed at the center of our solar system, its surface would extend beyond the orbit of Jupiter. Compared to other hypergiants, VY Canis Majoris is among the largest, though exact size rankings can be challenging due to the dynamic nature of these stars. It outshines many of its hypergiant peers in terms of luminosity, radiating energy at a rate tens of thousands of times greater than our Sun. This immense energy output is a characteristic shared by other hypergiants. But VY Canis Majoris pushes the upper limits. What sets VY Canis Majoris apart from many other hypergiants is its extreme mass loss rate. It sheds enormous amounts of material into space, creating a vast, complex nebula around itself. This rapid mass loss is common among hypergiants, but occurs at an exceptional rate in VY Canis Majoris. Despite its current grandeur, VY Canis Majoris, like other hypergiants, is in a precarious stage of its life. These massive stars are inherently unstable and short-lived compared to smaller stars. Astronomers expect VY Canis Majoris to end its life in a spectacular supernova explosion, a fate shared by many of its hypergiant counterparts. VY Canis Majoris stands out as one of the largest known stars in the universe, dwarfing our Sun in both size and luminosity. This hypergiant star, located in the constellation Canis Major, is estimated to have a radius between 1,400 and 2,100 times that of the Sun. To put this into perspective, if VY Canis Majoris were placed at the center of our solar system, its surface would extend beyond the orbit of Jupiter. The sheer mass of VY Canis Majoris is equally impressive, with estimates ranging from 17 to 40 times the mass of our Sun. This enormous mass, combined with its tremendous size, results in a star that shines with the luminosity of several 100,000 suns. The extreme nature of VY Canis Majoris makes it a prime subject for studying the upper limits of stellar evolution and the processes that occur in the most massive stars. Another distinguishing feature of VY Canis Majoris is its complex and dynamic atmosphere. The star is surrounded by an extensive envelope of dust and gas, which it continuously ejects into space. This material forms intricate structures and filaments, creating a nebula-like environment around the star. These ejections are a result of the intense stellar winds and unstable nature of such a massive star, providing astronomers with valuable insights into the late stages of stellar evolution for the most massive stars in the universe. VY Canis Majoris is also notable for its relatively short lifespan. While smaller stars like our Sun can exist for billions of years, VY Canis Majoris is expected to have a total lifetime of only a few million years. This rapid evolution, coupled with its extreme characteristics, makes it an invaluable target for astronomers studying the life cycles of the universe, most massive stars, and the processes that lead to their eventual demise as supernovae. VY Canis Majoris is indeed a stellar giant, but it's not alone in its colossal stature. Several other stars compete for the title of largest known star, each presenting its own set of awe-inspiring characteristics. One notable contender is UY Scuti, a hypergiant star in the constellation Scutum. Some measurements suggest it might even surpass VY Canis Majoris in size, with a radius potentially reaching over 1,500 times that of our Sun. Another massive star is Stephenson 2-18. located in the constellation Scutum as well. This red supergiant is estimated to have a radius about 1,350 times larger than our Sun. RW Cephei, found in the constellation Cepheus, is another enormous star that rivals VY Canis Majoris. Its exact size is difficult to determine due to its variable nature, but estimates place its radius at around 1,500 times that of the Sun. Westerland 1 W26, residing in the Westerland 1 star cluster, is yet another contender, with a radius potentially exceeding 1,500 solar radii. It's important to note that measuring the exact sizes of these stellar behemoths is challenging due to their immense distances from Earth and their often variable nature. As our observational techniques improve, our understanding of these cosmic giants continues to evolve, sometimes leading to revised estimates of their sizes. Stars like VY Canis Majoris are exceedingly rare in the universe. These hypergiant stars represent the upper extremes of stellar size and mass, pushing the boundaries of what we understand about stellar evolution. To put their rarity into perspective, for every star like VY Canis Majoris, there are millions of smaller, more common stars like our Sun. These hypergiants are so uncommon that astronomers estimate there might only be a few dozen in our entire Milky Way galaxy, which contains hundreds of billions of stars. The scarcity of these stellar giants is due to their short lifespans and the specific conditions required for their formation. They burn through their fuel at an incredibly rapid rate, living for only a few million years compared to the billions of years that smaller stars endure. This brief existence makes them challenging to observe and study. Furthermore, the formation of such massive stars requires exceptional circumstances, typically occurring in regions of intense star formation where there is an abundance of gas and dust. These conditions are not common, contributing to the rarity of stars like VY Canis Majoris across the cosmos. VY Canis Majoris stands as a testament to the extraordinary limits of stellar evolution. This hypergiant star, located in the constellation Canis Major, pushes our understanding of how massive a star can become before it succumbs to its own gravitational forces. With a radius estimated to be more than 1,000 times that of our Sun, VY Canis Majoris demonstrates the extreme sizes that stars can reach. Its enormous mass, believed to be around 30 to 40 times that of our Sun, showcases the delicate balance between radiation pressure and gravity that allows such massive stars to exist. However, VY Canis Majoris also reveals the instability of these stellar giants. It is losing mass at a tremendous rate, ejecting vast amounts of material into space. This rapid mass loss indicates that stars of this size are relatively short-lived, lasting only a few million years before they exhaust their fuel and end their lives in spectacular supernovae. By studying VY Canis Majoris, astronomers gain insights into the processes that govern stellar formation and evolution at the most extreme scales. It serves as a crucial data point in understanding the upper limits of stellar mass and size, helping refine our models of stellar physics and the life cycles of the most massive stars in the universe. The extreme rarity of hypergiant stars like VY Canis Majoris provides crucial insights into stellar evolution, particularly the final stages of massive stars. These cosmic behemoths, with their immense size and luminosity, represent a brief and turbulent phase in the lives of the most massive stars in the universe. Studying VY Canis Majoris and its equally rare counterparts allows astronomers to test and refine models of stellar physics under extreme conditions. These stars push the boundaries of our understanding, experiencing intense mass loss and exhibiting unstable atmospheres that challenge our theories of stellar structure and evolution. The scarcity of such stars also highlights the rapid nature of their evolution. They burn through their nuclear fuel at an astonishing rate, living for only a few million years compared to the billions of years typical for smaller stars. This short lifespan, combined with their rarity, makes each hypergiant a valuable cosmic laboratory. Furthermore, the study of these rare stellar giants provides clues about the chemical enrichment of the universe. When they eventually explode as supernovae, they scatter heavy elements across vast distances, contributing significantly to the composition of future stars and planets. Their rarity thus underscores their outsized role in cosmic chemistry and the cycle of stellar life and death. VY Canis Majoris, one of the largest known stars in our galaxy, has exhibited several intriguing features and behaviors that set it apart from other stellar objects. This hypergiant star, located in the constellation Canis Major, has a radius estimated to be around 1,500 times that of our Sun, making it an extraordinary cosmic entity. One of the most notable behaviors of VY Canis Majoris is its intense mass loss. The star is shedding material at an astonishing rate, expelling the equivalent of the Earth's mass every year. This extreme mass loss creates a vast, complex nebula surrounding the star, composed of dust and gas ejected from its surface. The nebula extends several light-years into space, forming intricate structures and filaments that astronomers continue to study. Another unique feature of VY Canis Majoris is its variable brightness. The star's luminosity fluctuates over time, a characteristic common to many red supergiants, but particularly pronounced in this case. These variations are thought to be caused by changes in the star's outer layers, possibly due to convection currents or pulsations within its enormous structure. The star also displays unusual spectral characteristics. Observations have revealed the presence of various molecules in its extended atmosphere, including water vapor and silicon oxide. These molecular signatures provide valuable information about the chemical composition and physical conditions in the outer regions of such massive stars, offering insights into their evolution and eventual fate. VY Canis Majoris, one of the largest known stars in our galaxy, pushes the boundaries of our understanding of stellar evolution and structure. This hypergiant star, with its enormous size and mass, presents several challenges to our current stellar models. The sheer scale of VY Canis Majoris is difficult to reconcile with traditional theories of stellar formation and growth. Its radius is estimated to be over 1,500 times that of our Sun, a size that our models struggle to explain. This extreme size raises questions about the mechanisms that allow a star to grow so large without becoming unstable and breaking apart. Another challenge lies in the star's mass loss rate. VY Canis Majoris is shedding mass at an incredibly rapid pace, much faster than our models predict for even the largest stars. This intense mass loss affects the star's evolution and lifespan in ways that are not fully understood, forcing scientists to re-evaluate their assumptions about the life cycles of hypergiant stars. The internal structure of VY Canis Majoris also poses problems for our current models. Its immense size suggests an extremely low density, particularly in its outer layers. This low density challenges our understanding of how such a star can maintain its shape and continue functioning as a coherent celestial body. As we study VY Canis Majoris and other hypergiant stars, we are compelled to refine and expand our stellar models to account for these extreme cases, pushing the boundaries of our knowledge about the universe's most massive stars. VY Canis Majoris, one of the largest known stars in our galaxy, continues to perplex astronomers with its extreme characteristics. This hypergiant star, located about 3,000 light-years from Earth, raises numerous questions about stellar evolution and the upper limits of stellar mass. One of the primary mysteries surrounding VY Canis Majoris is its precise size and mass. Due to its enormous distance and the presence of a thick dust envelope surrounding the star, accurate measurements have proven challenging. Estimates of its radius range from 1,400 to 2,900 times that of our Sun, highlighting the uncertainty in our understanding of its true dimensions. The star's mass loss rate is another puzzling aspect. VY Canis Majoris is shedding mass at an extraordinary rate, ejecting the equivalent of an Earth-sized planet every year. Scientists are still working to fully understand the mechanisms driving this intense mass loss and how it affects the star's evolution and eventual fate. Furthermore, the future of VY Canis Majoris remains uncertain. While many astronomers believe it will eventually explode as a supernova, the exact nature of this event and its timing are subjects of ongoing debate. Some theories suggest it might instead collapse directly into a black hole, bypassing the supernova stage entirely. These uncertainties underscore our limited understanding of the life cycles of the most massive stars in the universe. Canis Majoris, one of the largest known stars in our galaxy, offers a unique laboratory for astrophysicists to study extreme stellar physics. This hypergiant star, with its enormous size and mass, pushes the boundaries of our understanding of stellar evolution and structure. By observing Canis Majoris, scientists can gain insights into the late stages of massive star evolution. The star's intense mass loss and powerful stellar winds provide valuable data on how very massive stars shed material and interact with their surrounding environment. This information is crucial for refining models of stellar evolution and improving our predictions of how these giants end their lives. The study of Canis Majoris also sheds light on the processes of element creation and distribution in the universe. As a highly evolved star, it produces and expels heavy elements into space, contributing to the chemical enrichment of the galaxy. Understanding these processes can help us trace the origin of elements necessary for life and planetary formation. Furthermore, the extreme conditions found in and around Canis Majoris offer opportunities to test theories of physics under circumstances impossible to replicate on Earth. This includes studying plasma dynamics, magnetic fields, and even the behavior of matter under intense radiation and gravity. Such research could lead to breakthroughs in our understanding of fundamental physics and potentially uncover new phenomena. Canis Majoris, one of the largest known stars in our galaxy, faces a tumultuous future. This hypergiant star, located roughly 3,000 light-years from Earth, is already in the late stages of its stellar life. As it continues to evolve, Canis Majoris will undergo dramatic changes that will ultimately lead to its demise. In the coming thousands of years, this massive star will continue to shed its outer layers through powerful stellar winds and eruptions. This process will cause Canis Majoris to lose significant amounts of mass, potentially shrinking in size while simultaneously expanding its surrounding nebula. The star's instability will likely increase, leading to more frequent and intense periods of mass loss. Eventually, Canis Majoris will exhaust its nuclear fuel, triggering a catastrophic collapse of its core. Given its extreme mass, astronomers predict that this collapse will result in a spectacular supernova explosion. This event will outshine entire galaxies for a brief period, dispersing heavy elements forged within the star throughout space. The fate of Canis Majoris after its supernova remains a subject of scientific debate. Some models suggest it may form a black hole, while others propose it could leave behind a neutron star. Regardless of the outcome, the death of this cosmic giant will undoubtedly leave a lasting impact on its galactic neighborhood, enriching the interstellar medium and potentially triggering the formation of new stars and planets. Canis Majoris, one of the largest known stars in our galaxy, is nearing the end of its stellar life. This hypergiant star, located in the constellation Canis Major, is expected to conclude its existence within the next 100,000 to 500,000 years. While this might seem like an incredibly long time from a human perspective, it is merely a blink of an eye in cosmic terms. The exact timing of Canis Majoris's demise is challenging to predict with precision due to the complex nature of stellar evolution, especially for stars of such immense size. Astronomers base their estimates on observations of the star's current state and our understanding of stellar physics. The star is already in an unstable phase, shedding large amounts of mass through powerful stellar winds. When Canis Majoris does reach the end of its life, the event will be spectacular. Given its enormous mass, the star is expected to explode as a supernova, briefly outshining entire galaxies. This cataclysmic event will scatter heavy elements forged in the star's core across space, potentially seeding the formation of new stars and planets. The relatively short remaining lifespan of VY Canis Majoris offers astronomers a unique opportunity to study the late stages of stellar evolution in real time. Observations of this star and others like it contribute significantly to our understanding of the life cycles of the most massive stars in the universe. VY Canis Majoris, one of the largest known stars in our galaxy, is destined for a spectacular end. This hypergiant star is expected to produce a rare and powerful type of stellar explosion known as a hypernova. Hypernovae are exceptionally energetic supernovae that release immense amounts of energy, far surpassing that of typical supernovae. The fate of VY Canis Majoris is tied to its enormous mass, which is estimated to be around 40 times that of our Sun. Stars this massive undergo rapid fusion processes throughout their lives, burning through their nuclear fuel at an accelerated rate. As VY Canis Majoris nears the end of its life, it will likely collapse under its own gravity, triggering a cataclysmic explosion. During this hypernova event, the core of VY Canis Majoris is expected to form a black hole. The formation of this black hole, combined with the collapse of the star's outer layers, will release an enormous amount of energy. This energy will be emitted in the form of intense radiation and powerful jets of matter, making the explosion visible across vast cosmic distances. The hypernova of VY Canis Majoris will not only be a spectacular sight, but also a significant cosmic event. It will distribute heavy elements forged within the star throughout space, contributing to the chemical enrichment of the galaxy and potentially seeding the formation of future stars and planets. VY Canis Majoris, one of the largest known stars in our galaxy, will have a profound impact on its surrounding space when it reaches the end of its life. This hypergiant star, with a radius roughly 1,400 times that of our Sun, is expected to die in a spectacular supernova explosion. When VY Canis Majoris explodes, it will release an enormous amount of energy, briefly outshining entire galaxies. This cosmic event will propel vast quantities of heavy elements into space, enriching the interstellar medium with materials crucial for the formation of new stars, planets, and potentially life itself. The supernova will also generate powerful shock waves that will sweep through the surrounding region, compressing nearby gas and dust clouds. This compression could trigger the birth of new stars, creating a wave of stellar formation in the vicinity. Additionally, the explosion will leave behind a remnant, likely a black hole, which will continue to influence its cosmic neighborhood through its intense gravitational pull. The death of VY Canis Majoris will not only reshape its immediate surroundings, but also contribute to the ongoing cycle of stellar life and death in our galaxy. Its legacy will persist for millions of years, influencing the evolution of its corner of the Milky Way and demonstrating the dynamic nature of our universe. VY Canis Majoris, one of the largest known stars in our galaxy, will leave behind a fascinating remnant when it reaches the end of its life. This hypergiant star, with its enormous size and mass, is destined for a spectacular finale. Given its tremendous mass, VY Canis Majoris is expected to end its life in a powerful supernova explosion. This cataclysmic event will scatter much of the star's outer layers into space, enriching the surrounding interstellar medium with heavy elements forged within its core. The fate of its core, however, is particularly intriguing. Due to the star's extreme mass, the remnant left behind after the supernova is likely to be a black hole. This black hole would be formed from the collapsed core of VY Canis Majoris, with a gravitational pull so intense that not even light can escape its grasp. Surrounding this newly formed black hole, we might find a nebula composed of the ejected outer layers of the former star. This nebula would gradually disperse over time, leaving the black hole as the enduring legacy of VY Canis Majoris, a silent sentinel in the cosmic night. VY Canis Majoris, one of the largest known stars in our galaxy, will play a crucial role in the cosmic cycle of stellar birth and death when it reaches the end of its life. This behemoth star, with a mass estimated at around 40 times that of our Sun, is destined for a spectacular demise as a supernova. When VY Canis Majoris explodes, it will unleash an enormous amount of energy and scatter its outer layers across a vast region of space. This explosive event will propel heavy elements forged within the star's core out into the surrounding interstellar medium. These elements, including carbon, oxygen, and heavier metals, are essential building blocks for future generations of stars and planets. The ejected material from Canis Majoris will mix with existing gas and dust in space, enriching and energizing these cosmic clouds. As these clouds cool and condense over millions of years, they will eventually collapse under their own gravity, forming new stars and potentially planetary systems. This process of stellar recycling ensures that the elements created inside massive stars like Canis Majoris become incorporated into new cosmic structures. Furthermore, the shockwave from the supernova explosion can trigger the collapse of nearby gas clouds, accelerating the star formation process in its vicinity. In this way, the death of Canis Majoris will not only provide the raw materials for new stars, but may also actively stimulate their birth, continuing the grand cycle of stellar evolution in our galaxy. The death of Canis Majoris, one of the largest known stars in our galaxy, will have a profound impact on the chemical composition of its surrounding space. When this hypergiant star eventually explodes as a supernova, it will unleash an enormous amount of energy and scatter its constituent elements across a vast region of space. During its life, Canis Majoris has been producing heavy elements through nuclear fusion in its core. These elements include carbon, oxygen, and even heavier elements like iron. When the star dies, these elements will be violently ejected into space, enriching the interstellar medium with a diverse array of chemical components. This process, known as stellar nucleosynthesis, is crucial for the chemical evolution of galaxies. The material expelled by Canis Majoris will eventually mix with existing gas and dust in space, forming new molecular clouds. These enriched clouds will become the birthplaces of future stars and planets, potentially creating environments more conducive to the formation of complex molecules and even life. Furthermore, the intense energy released during the supernova explosion will trigger the creation of even heavier elements through rapid neutron capture. This will contribute to the galactic abundance of rare elements like gold, platinum, and uranium. The death of Canis Majoris will serve as a cosmic factory, producing and distributing the building blocks for future celestial bodies throughout its galaxy. The supernova of Canis Majoris will be a spectacular cosmic event, visible across an enormous expanse of our galaxy and beyond. This hypergiant star, one of the largest known in the universe, is expected to produce an exceptionally bright explosion when it reaches the end of its life. Given its immense size and energy output, the light from Canis Majoris's supernova will likely be visible from distances measuring in the tens of thousands of light-years. In fact, it could potentially be seen from nearly anywhere within the Milky Way galaxy, which spans approximately 100,000 light-years in diameter. The brightness of this future supernova might even allow it to be observed in neighboring galaxies. Astronomers predict that the explosion could be visible to the naked eye from Earth for several weeks or even months, despite Canis Majoris being located about 3,900 light-years away from us. However, the exact visibility distance will depend on various factors, including the specific type of supernova, the amount of interstellar dust between the star and observers, and the sensitivity of detection equipment used by astronomers across the cosmos. Regardless, when Canis Majoris finally explodes, it will undoubtedly provide a dazzling light show for a significant portion of our cosmic neighborhood. Canis Majoris, one of the largest known stars in our galaxy, serves as a cosmic laboratory for understanding the life cycles of massive stars. This hypergiant star, with its enormous size and unstable nature, provides astronomers with valuable insights into the final stages of stellar evolution for the most massive stars in the universe. By studying Canis Majoris, scientists can predict the fate of other massive stars and gain a deeper understanding of the processes that shape the cosmos. As this behemoth nears the end of its life, it is shedding vast amounts of material into space, creating a complex nebula around itself. This mass loss offers clues about how other massive stars might behave in their twilight years. The fate of VY Canis Majoris is likely to be a spectacular supernova explosion which will briefly outshine its entire host galaxy. This event will offer a preview of the dramatic endings awaiting other massive stars. By observing the lead-up to this cosmic finale, astronomers can refine their models of stellar evolution and better predict when and how other giant stars might meet their explosive ends. Furthermore, the study of VY Canis Majoris and its eventual demise will shed light on the crucial role massive stars play in enriching the universe with heavy elements. These elements, forged in the cores of giant stars and scattered by supernovae, are essential for the formation of planets and ultimately life as we know it. Understanding the life cycle of VY Canis Majoris thus provides a window into the cosmic processes that make our existence possible. The death of VY Canis Majoris, one of the largest known stars in our galaxy, would be a spectacular cosmic event with far-reaching implications for our understanding of the universe. This hypergiant star, located approximately 3,900 light-years from Earth, is nearing the end of its life, and its eventual demise will offer astronomers a rare opportunity to study the final stages of massive stellar evolution. When VY Canis Majoris explodes as a supernova, it will release an enormous amount of energy and material into space. This explosion will allow scientists to observe the creation and distribution of heavy elements, which are crucial for the formation of planets and life as we know it. By analyzing the composition of the ejected material, researchers can refine their models of stellar nucleosynthesis and gain insights into the cosmic origins of various elements. Furthermore, the death of such a massive star could potentially result in the formation of a black hole. Observing this process in real time would provide valuable data on the physics of extreme gravitational environments and the behavior of matter under intense conditions. This information could help bridge the gap between quantum mechanics and general relativity, potentially leading to a more unified understanding of the fundamental laws governing our universe. The sheer scale of VY Canis Majoris means its death will be visible across vast distances, allowing astronomers to use it as a cosmic lighthouse to study the intervening space between Earth and the star. This could reveal new information about the structure and composition of interstellar matter, contributing to our understanding of galactic evolution and the distribution of dark matter in the universe. VY Canis Majoris has captured the imagination of popular science media as an exemplar of stellar extremes. This red hypergiant star has been frequently featured in documentaries, articles, and online videos as one of the largest known stars in our galaxy. Its enormous size has been a subject of fascination, often compared to familiar objects to help viewers grasp its scale. Many presentations describe VY Canis Majoris as being so vast that if it were placed at the center of our solar system, its surface would extend beyond the orbit of Jupiter. This comparison has become a staple in discussions about stellar sizes, helping to illustrate the star's immense proportions in relatable terms. However, it's important to note that our understanding of VY Canis Majoris has evolved over time. Earlier estimates of its size were even larger, leading to some outdated portrayals in older media. More recent observations have refined our measurements, showing that while VY Canis Majoris is indeed extraordinarily large, it may not be quite as enormous as once thought. Despite these revisions, VY Canis Majoris continues to be a popular subject in science communication, serving as a prime example of the extreme diversity found in stellar objects and the ongoing nature of astronomical research. The discovery of VY Canis Majoris has significantly boosted public interest in astronomy, captivating people with its sheer enormity. This hypergiant star, located in the constellation Canis Major, is one of the largest known stars in the universe. Its colossal size, estimated to be between 1,400 and 2,600 times the radius of our Sun, has sparked curiosity and wonder among both amateur stargazers and professional astronomers. The star's discovery has served as a powerful reminder of the vastness of the cosmos and our relatively small place within it. It has become a popular subject in science, documentaries, astronomy books, and educational programs, helping to illustrate the extreme diversity of stellar objects in the universe. This increased exposure has drawn more people into the field of astronomy, encouraging them to learn about stellar evolution and the life cycles of stars. Canis Majoris has also played a role in expanding our understanding of stellar physics. Its existence challenges previous models of star formation and evolution, prompting researchers to refine their theories and develop new models to explain how such massive stars can form and persist. This ongoing scientific inquiry has further fueled public interest, as people are drawn to the dynamic nature of astronomical research and the constant expansion of our knowledge. Moreover, the star has become a source of inspiration for artists, writers, and filmmakers, appearing in various forms of media and popular culture. This cultural impact has helped bridge the gap between scientific discovery and public engagement, making astronomy more accessible and exciting to a broader audience. Canis Majoris, one of the largest known stars in our galaxy, has captured the imagination of science fiction creators, appearing in various works as a backdrop for epic space adventures and as a symbol of the vast scale of the universe. In literature, authors have used Canis Majoris as a setting for stories involving advanced civilizations and interstellar travel. Some narratives depict the star as a destination for explorers seeking to unravel cosmic mysteries or harness its immense energy. Other stories use the star's enormous size to illustrate the challenges of space exploration and the potential dangers lurking in the cosmos. Films and television shows have also featured Canis Majoris, often as a visual spectacle to convey the awe-inspiring nature of space. Special effects teams have created stunning renderings of the hypergiant star, showcasing its massive size compared to our Sun and other celestial objects. These depictions serve to emphasize the vastness of space and the relative insignificance of humanity in the grand scheme of the universe. While not always scientifically accurate, these fictional portrayals of Canis Majoris have helped to popularize astronomical concepts and inspire public interest in space exploration. The star's inclusion in science fiction works has contributed to its status as a cultural touchstone for discussions about the nature of the universe and our place within it. Canis Majoris, a red hypergiant star in the constellation Canis Major, has been the subject of several misconceptions in popular culture. One common error is the exaggeration of its size. While Canis Majoris is indeed enormous, some sources have claimed it to be the largest known star in the universe. This is not accurate, as more recent observations have revealed even larger stars. Another misconception involves the stability of Canis Majoris. Some popular accounts portray it as a stable, long-lasting giant. In reality, this star is highly unstable and rapidly losing mass through powerful stellar winds. It is nearing the end of its life and will likely explode as a supernova in the astronomically near future. The distance of Canis Majoris from Earth is often misrepresented. While it is far away, some sources greatly exaggerate this distance, placing it much farther than its actual location of about 3,900 light-years from our solar system. Lastly, there is a tendency to oversimplify the structure of Canis Majoris. It is often depicted as a perfect sphere, when in fact its shape is highly irregular due to its intense mass loss and the complex interactions between its stellar wind and the surrounding interstellar medium. These misconceptions highlight the importance of relying on current scientific data rather than outdated or sensationalized information. Canis Majoris, one of the largest known stars in the universe, has captured the imagination of artists and creators across various media. This colossal red hypergiant star, with its immense size and brilliant luminosity, serves as a powerful symbol of the vast scale and beauty of the cosmos. In visual arts, Canis Majoris has inspired painters and digital artists to create stunning depictions of its enormous red form, often juxtaposed against familiar celestial objects, to emphasize its incredible scale. These artworks frequently portray the star as a looming, fiery giant, dwarfing planets and even entire solar systems, helping viewers grasp the almost incomprehensible size of this celestial behemoth. Science fiction writers have also drawn inspiration from VY Canis Majoris, incorporating it into their stories as a setting for epic space adventures or as a source of exotic stellar phenomena. The star's extreme properties make it an ideal backdrop for tales of advanced civilizations, cosmic mysteries, and the exploration of the limits of known physics. Musicians and composers have found inspiration in the concept of VY Canis Majoris, creating pieces that attempt to convey the awe-inspiring nature of such a massive star through sound. These compositions often feature expansive, sweeping melodies and deep, resonant tones to evoke the sense of enormity and power associated with this stellar giant. VY Canis Majoris serves as a captivating example of stellar extremes in astronomy, education, and outreach. This red hypergiant star, located in the constellation Canis Major, is one of the largest known stars in our galaxy. Its immense size, estimated to be between 1,400 and 2,600 times the radius of our Sun, helps illustrate the vast scale of celestial objects in the universe. Educators and science communicators often use VY Canis Majoris to demonstrate the concept of stellar evolution. The star represents a late stage in the life cycle of very massive stars, showcasing how these cosmic giants expand to enormous proportions before ending their lives in spectacular supernova explosions. This makes it an excellent tool for teaching about the different types of stars and their fates. The star also plays a crucial role in sparking public interest in astronomy. Its superlative size captures the imagination, making it a popular subject in planetarium shows, astronomy documentaries, and public lectures. By comparing VY Canis Majoris to more familiar objects like our Sun or even our entire solar system, educators can effectively convey the mind-boggling scale of the universe. Furthermore, VY Canis Majoris helps highlight the ongoing nature of astronomical research. As studies of the star continue, our understanding of its properties evolves, demonstrating to the public how science is a dynamic, ever-changing process of discovery and refinement. Social media has played a significant role in spreading awareness about VY Canis Majoris, one of the largest known stars in our galaxy. Platforms like YouTube, Facebook, and Twitter have become powerful tools for sharing astronomical discoveries and fascinating cosmic objects with the general public. Viral videos and infographics comparing the size of VY Canis Majoris to other stars and our Sun have captured the imagination of millions of viewers. These visual representations help people grasp the enormous scale of this hypergiant star, which is estimated to be up to 2,000 times the size of our Sun. Astronomy enthusiasts and science communicators have used social media to share interesting facts about VY Canis Majoris, such as its location in the constellation Canis Major and its classification as a red hypergiant star. This information, often presented in easily digestible formats, has reached audiences who might not typically engage with traditional scientific publications. The star's extreme properties, including its massive size and luminosity, have made it a popular subject for online discussions and debates. Social media has allowed people to ask questions, share theories, and learn from experts, fostering a greater interest in astrophysics and stellar evolution among the general public. To grasp the immense size of VY Canis Majoris, astronomers often turn to our own solar system for comparison. If this hypergiant star were to replace our Sun at the center of our solar system, its surface would extend far beyond the orbit of Jupiter. In fact, its outer edge would reach somewhere between the orbits of Saturn and Uranus, engulfing everything closer to the Sun. Another popular analogy compares VY Canis Majoris to Earth. If our planet were the size of a penny, VY Canis Majoris would be as large as a skyscraper towering over 1.5 kilometers high. This stark contrast highlights the star's colossal dimensions and puts its size into a more relatable perspective. Some scientists use travel time to illustrate the star's magnitude. A commercial airliner flying at typical cruising speed would take well over 1,000 years to complete a single trip around VY Canis Majoris. This journey would be so vast that it would span multiple human lifetimes, emphasizing the star's extraordinary circumference. Lastly, volume comparisons often showcase the star's enormity. VY Canis Majoris could contain billions of suns within its boundaries. If our sun were a beach ball, VY Canis Majoris would be large enough to fill a football stadium many times over. These analogies help us comprehend the sheer scale of one of the largest known stars in our universe, bridging the gap between cosmic proportions and everyday understanding. VY Canis Majoris has captured the public imagination as an emblem of cosmic enormity. When first discovered, this red hypergiant star was thought to be among the largest known stars in the universe. Early estimates suggested it could be more than 2,000 times the size of our Sun, with a radius that would extend beyond the orbit of Saturn if placed at the center of our solar system. However, as our understanding of stellar physics and measurement techniques improved, the estimated size of VY Canis Majoris has been revised. More recent calculations indicate it is smaller than initially believed, though still impressively large. Current estimates place its radius at about 1,000 times that of the Sun, which would still engulf the orbit of Jupiter in our solar system. This evolving understanding of VY Canis Majoris reflects the dynamic nature of astronomical research. As new data becomes available and measurement methods advance, our perception of cosmic objects can change. Despite the downward revision of its size, VY Canis Majoris remains an object of fascination, representing the extreme scales found in our universe. The star continues to serve as a powerful example in discussions about stellar evolution, the life cycles of massive stars, and the sheer scale of cosmic objects. Its story reminds us that our understanding of the universe is constantly refining, with each new discovery adding nuance to our cosmic perspective. VY Canis Majoris, one of the largest known stars in our galaxy, has captured the imagination of astronomers and the public alike. While not as culturally significant as some other celestial objects, this hypergiant star has become a symbol of the sheer scale and wonder of the universe. In recent years, VY Canis Majoris has gained popularity in educational contexts, often used to illustrate the vast differences in stellar sizes. Educators and science communicators frequently use comparisons between this star and our Sun to help students and the general public grasp the enormous scale of cosmic objects. This has led to its inclusion in numerous documentaries, educational videos, and popular science books. The star has also made its way into popular culture, appearing in science fiction, literature, and space-themed video games. In these contexts, VY Canis Majoris often serves as a backdrop for epic space adventures or as a destination for fictional interstellar travelers, highlighting its status as an awe-inspiring cosmic landmark. While not holding the same cultural significance as constellations or planets that have been known for millennia, VY Canis Majoris represents humanity's ongoing fascination with the extremes of the universe. It serves as a reminder of how much there is still to discover and understand about the cosmos, inspiring curiosity and wonder in both scientific and public spheres. The study of VY Canis Majoris, one of the largest known stars in our galaxy, has been greatly enhanced by several key technological advancements. Infrared astronomy has played a crucial role in observing this hypergiant star, allowing scientists to peer through the thick clouds of dust that surround it. Powerful space-based telescopes like the Hubble Space Telescope have provided unprecedented clarity in imaging VY Canis Majoris, revealing intricate details of its structure and behavior. Adaptive optics systems on ground-based telescopes have also been instrumental in studying this massive star. These systems correct for atmospheric distortions, enabling sharper and more detailed observations from Earth. Spectroscopy has been another vital tool, allowing astronomers to analyze the chemical composition and physical properties of VY Canis Majoris by examining the light it emits. Advanced computer modeling and simulation techniques have helped scientists interpret the vast amount of data collected on this star. These models allow researchers to better understand the complex processes occurring within and around VY Canis Majoris, including its intense mass loss and the formation of its extended atmosphere. Radio astronomy has contributed to our knowledge of the star's surrounding environment, detecting molecules in the cool outer regions of its atmosphere. The combination of these technologies has provided a comprehensive view of VY Canis Majoris, shedding light on its extraordinary size, mass, and evolutionary state. Astronomers employ a range of sophisticated techniques and advanced technologies to observe distant celestial objects. One key method is the use of powerful telescopes, both on Earth and in space, that can gather faint light from far-off sources. These telescopes often have large mirrors or arrays of mirrors to collect as much light as possible, allowing astronomers to detect objects billions of light-years away. Space-based observatories like the Hubble Space Telescope and the James Webb Space Telescope play a crucial role in overcoming the limitations of Earth's atmosphere. By operating above our planet's distorting air, these telescopes can capture clearer, more detailed images of distant objects. They also have the advantage of being able to detect wavelengths of light that are blocked by Earth's atmosphere, such as certain types of infrared radiation. Astronomers also use a technique called adaptive optics to counteract the blurring effects of Earth's atmosphere for ground-based telescopes. This involves using flexible mirrors that can rapidly change shape to compensate for atmospheric distortions, resulting in much sharper images. Another powerful tool is interferometry, where multiple telescopes work together to act as a single, much larger telescope, greatly increasing the resolution of observations. To study the faintest and most distant objects, astronomers often employ long exposure times, sometimes observing the same area of sky for hundreds of hours. They also use spectroscopy to analyze the light from distant objects, revealing information about their composition, temperature, and motion. These combined approaches allow astronomers to push the boundaries of observation, studying objects at the very edge of the observable universe. Computer modeling plays a crucial role in our understanding of VY Canis Majoris, one of the largest known stars in the universe. These sophisticated simulations allow astronomers to study the complex processes occurring within and around this hypergiant star, which would otherwise be impossible to observe directly. By creating virtual models of VY Canis Majoris, scientists can simulate its internal structure, temperature distribution, and the intense stellar winds that shape its surrounding environment. These models help researchers predict how the star's mass loss affects its evolution and ultimate fate. They also provide insights into the formation of dust and molecules in the star's extended atmosphere, which is critical for understanding the chemical enrichment of the interstellar medium. Furthermore, computer simulations enable astronomers to test different theories about the star's behavior and compare the results with observational data. This process helps refine our knowledge of stellar physics and improves our ability to understand other massive stars in the universe. The models also assist in interpreting the complex spectral data collected from VY Canis Majoris, allowing scientists to deduce its composition and physical properties more accurately. As our computing power continues to increase, these models become more sophisticated, incorporating more variables and producing more accurate predictions. This ongoing improvement in computer modeling is essential for advancing our understanding of extreme stellar objects like VY Canis Majoris and pushing the boundaries of astrophysical knowledge. Spectroscopy has been instrumental in revealing the extraordinary nature of VY Canis Majoris, one of the largest known stars in our galaxy. This powerful technique allows astronomers to analyze the light emitted by celestial objects, providing crucial information about their composition, temperature, and motion. For VY Canis Majoris, spectroscopic observations have unveiled its status as a red hypergiant star, placing it among the most massive and luminous stars known. The star's spectrum shows strong emission lines of various elements, particularly hydrogen and oxygen, indicating an extensive and complex atmosphere. Spectroscopy has also revealed the presence of numerous molecules in the star's extended envelope, including water, hydroxyl, and silicon oxide. These findings suggest ongoing mass loss and provide insights into the chemical processes occurring in the star's outer layers. Furthermore, the Doppler shift, observed in the spectral lines, has allowed astronomers to measure the star's radial velocity and estimate its distance from Earth. Perhaps most intriguingly, spectroscopic data have helped scientists track VY Canis Majoris' evolution and predict its future. The star's spectrum indicates that it is in an advanced stage of its life, shedding enormous amounts of material as it approaches the end of its stellar journey. This information has been crucial in understanding the life cycles of massive stars and their role in enriching the interstellar medium with heavy elements. Our study of VY Canis Majoris, one of the largest known stars in the universe, faces several technological hurdles. The sheer distance to this hypergiant star, approximately 3,900 light-years from Earth, poses a significant challenge. Even our most powerful telescopes struggle to capture detailed images of its surface and surrounding environment. The extreme size and brightness of VY Canis Majoris also complicate observations. Its immense luminosity, over several 100,000 times that of our Sun, can overwhelm sensitive instruments, making it difficult to discern finer details. This brightness issue is compounded by the thick envelope of dust and gas surrounding the star, obscuring our view of its true surface. Current spectroscopic techniques, while advanced, still have limitations when analyzing such a massive and complex stellar object. The unusual composition and behavior of VY Canis Majoris push the boundaries of our models and theories, making it challenging to interpret the data we gather accurately. Furthermore, the dynamic nature of this star, with its ongoing mass loss and potential for sudden changes, requires long-term monitoring that stretches the capabilities of our current observational networks. Coordinating multiple observatories for extended periods to track its evolution remains a logistical challenge in the field of astronomy. Future space telescopes will revolutionize our understanding of VY Canis Majoris, one of the largest known stars in the universe. These advanced instruments will offer unprecedented clarity and detail, allowing astronomers to peer deeper into the complex structure of this hypergiant star. High-resolution imaging capabilities will reveal the intricate patterns of VY Canis Majoris' enormous stellar atmosphere, helping scientists map its turbulent surface and the vast clouds of dust and gas surrounding it. This improved view will provide crucial insights into the star's mass loss processes and the mechanisms driving its incredible size and luminosity. Spectroscopic advancements in future telescopes will enable more precise measurements of VY Canis Majoris' chemical composition. By analyzing the light emitted from different regions of the star, astronomers will gain a better understanding of its internal structure and the nuclear reactions occurring within its core. Moreover, these next-generation instruments will allow for long-term monitoring of VY Canis Majoris, tracking changes in its brightness, size, and behavior over time. This extended observation period will be invaluable in predicting the star's future evolution and ultimate fate, shedding light on the life cycles of the most massive stars in the universe. Adaptive optics plays a crucial role in imaging distant celestial objects like VY Canis Majoris, a hypergiant star located approximately 3,000 light-years from Earth. This technology helps astronomers overcome the limitations imposed by Earth's turbulent atmosphere, which distorts incoming light and blurs our view of the cosmos. When observing VY Canis Majoris, adaptive optics systems use deformable mirrors that rapidly change shape to counteract atmospheric distortions. These systems measure the wavefront of incoming light and adjust the mirror's surface hundreds of times per second. This process effectively cancels out the atmospheric turbulence, allowing telescopes to capture much sharper and more detailed images of the star. For VY Canis Majoris, adaptive optics has revealed intricate details of its vast, complex atmosphere and surrounding dust clouds. Without this technology, much of the star's structure would remain hidden from view. Adaptive optics has enabled astronomers to study the star's intense mass loss processes, its irregular shape, and the dynamic interactions between the star and its environment. By providing clearer images, adaptive optics also allows scientists to better estimate VY Canis Majoris' size, temperature, and composition. This information is crucial for understanding the life cycles of massive stars and their impact on galactic evolution. The improved resolution offered by adaptive optics continues to push the boundaries of our knowledge about these extraordinary cosmic objects. Astronomers face significant challenges when observing VY Canis Majoris due to atmospheric distortion. This enormous red hypergiant star, located approximately 3,000 light-years from Earth, requires precise measurements to understand its true size and characteristics. To combat atmospheric interference, astronomers employ several sophisticated techniques. One primary method is adaptive optics, which uses deformable mirrors to correct for atmospheric turbulence in real time. This technology allows telescopes to achieve near-diffraction limited observations, dramatically improving image quality. Another crucial approach is speckle interferometry. This technique involves taking many short exposure images of the star and then using computer algorithms to reconstruct a clearer, sharper image. By combining these rapid snapshots, astronomers can effectively freeze the atmospheric turbulence and reveal finer details of VY Canis Majoris. Space-based observations also play a vital role in studying this massive star. Telescopes like the Hubble Space Telescope, operating above Earth's atmosphere, provide unobstructed views of VY Canis Majoris. These observations, free from atmospheric distortion, offer valuable data that complement ground-based studies and help astronomers build a more accurate picture of this extraordinary stellar object. The sheer luminosity of VY Canis Majoris presents significant challenges for astronomers attempting to study this colossal star. As one of the most luminous known stars in our galaxy, its intense brightness can overwhelm sensitive observational instruments, making it difficult to gather accurate data. The extreme radiation output of VY Canis Majoris creates a glare effect that obscures finer details of the star's structure and immediate surroundings. This phenomenon is akin to trying to discern the features of a light bulb while it's turned on. The intense light drowns out subtler features, complicating efforts to understand the star's exact size, mass, and composition. Furthermore, the star's brightness affects observations of nearby celestial objects. The light from VY Canis Majoris can spill over into adjacent areas of the sky, potentially masking or distorting the appearance of neighboring stars or cosmic structures. This effect necessitates careful calibration and advanced imaging techniques to separate the star's influence from other objects of interest in its vicinity. Despite these challenges, astronomers have developed specialized tools and methods to study VY Canis Majoris. These include using filters to reduce the star's overwhelming brightness and employing adaptive optics to counteract atmospheric distortion. Such techniques allow researchers to peer through the dazzling luminosity and uncover the secrets of this extraordinary stellar giant. Gravitational wave detection has opened up a new frontier in astronomy, allowing us to observe cosmic events in ways previously impossible. For massive stars like VY Canis Majoris, these advances could provide unprecedented insights into their structure and evolution. As these enormous stars near the end of their lives, they undergo violent internal processes that could potentially generate detectable gravitational waves. The extreme mass and size of VY Canis Majoris make it an ideal candidate for such observations. By detecting and analyzing these gravitational waves, scientists could gain a deeper understanding of the star's core, its composition, and the complex dynamics occurring within its vast envelope. Furthermore, when stars like VY Canis Majoris eventually collapse and explode as supernovae, they are expected to produce powerful gravitational wave signals. These signals could offer valuable information about the final moments of these stellar giants and the mechanisms behind their spectacular deaths. Such data would be instrumental in refining our models of stellar evolution and the life cycles of the most massive stars in the universe. Advances in gravitational wave detection might also allow us to observe previously unknown phenomena associated with these hypergiant stars. As our detection capabilities improve, we may uncover new types of stellar oscillations, internal structural changes, or even exotic objects within these stellar behemoths, further expanding our knowledge of the extreme physics at play in the cosmos. VY Canis Majoris, one of the largest known stars in our galaxy, serves as a cosmic laboratory for astronomers studying the extreme limits of stellar physics. This hypergiant star, with its enormous size and mass, pushes the boundaries of our understanding of stellar evolution and structure. By observing VY Canis Majoris, scientists gain insights into the late stages of massive star evolution. Its immense size and high mass loss rate provide valuable data on how stars shed their outer layers, a process crucial to understanding the life cycles of stars and their impact on galactic chemistry. The star's extreme luminosity and temperature also offer a unique opportunity to study stellar atmospheres under extreme conditions. This helps refine models of stellar interiors and energy transfer mechanisms in stars much larger than our Sun. Furthermore, studying VY Canis Majoris aids in understanding the upper limits of stellar mass and size. This knowledge is vital for predicting the eventual fate of massive stars and their potential to form black holes or undergo supernova explosions, processes that play a significant role in shaping the universe around us. VY Canis Majoris, one of the largest known stars in our galaxy, offers astronomers valuable insights into the extreme processes of stellar formation and evolution. This hypergiant star, with a radius estimated to be over 1,000 times that of our Sun, showcases the upper limits of stellar mass and size. The sheer scale of VY Canis Majoris demonstrates how massive stars can become under certain conditions. Its enormous size is a result of intense fusion reactions in its core, which have caused the star to expand dramatically. This expansion tells us about the delicate balance between gravity and radiation pressure in ultramassive stars. Studying VY Canis Majoris also reveals the complex stages of stellar evolution for the most massive stars. Unlike smaller stars that transition smoothly from one phase to another, VY Canis Majoris exhibits signs of instability and intense mass loss. This indicates that very massive stars undergo more turbulent and rapid evolutionary processes. The star's composition and behavior provide clues about the enrichment of the interstellar medium. As VY Canis Majoris sheds its outer layers, it disperses heavy elements forged in its core into space. This process illustrates how the largest stars play a crucial role in seeding the cosmos with the materials necessary for future generations of stars and planets. VY Canis Majoris, a hypergiant star in the constellation Canis Major, presents a significant challenge to our understanding of stellar structure and evolution. This colossal star, with a radius estimated to be over 1,500 times that of our Sun, pushes the boundaries of what we thought possible for stellar size. The sheer scale of VY Canis Majoris defies conventional stellar models. Its enormous mass and volume create conditions that are difficult to reconcile with our current theories of stellar physics. The star's outer layers are so vast and diffuse that they barely cling to the star, constantly shedding material into space. This extreme mass loss rate is not well explained by standard stellar wind models. Furthermore, the internal structure of VY Canis Majoris is a mystery. Traditional models of stellar interiors struggle to account for the extreme conditions within such a massive star. The intense radiation pressure and turbulent convection occurring inside VY Canis Majoris likely create unique phenomena that our current models cannot accurately predict or explain. The existence of VY Canis Majoris also raises questions about the upper limits of stellar mass and size. It challenges astronomers to refine their theories and develop new models that can account for these extreme stellar objects. As we continue to study VY Canis Majoris and other hypergiant stars, we may need to revise our understanding of stellar formation, evolution, and the physical processes that govern the largest stars in the universe. VY Canis Majoris, one of the largest known stars in our galaxy, has offered astronomers valuable insights into stellar magnetism, particularly in massive, evolved stars. This hypergiant star, located in the constellation Canis Major, exhibits complex magnetic fields that challenge our understanding of stellar physics. Observations of VY Canis Majoris have revealed the presence of strong, localized magnetic fields on its surface. These fields are thought to play a crucial role in shaping the star's extensive atmosphere and influencing its dramatic mass loss. The star's enormous size and low surface gravity make it an ideal laboratory for studying how magnetic fields interact with stellar material in extreme conditions. Researchers have detected polarized light from VY Canis Majoris, indicating the presence of magnetized dust grains in its extended atmosphere. This finding suggests that magnetic fields may be instrumental in lifting material away from the star's surface, contributing to the formation of its vast, complex, circumstellar environment. The study of VY Canis Majoris has also provided clues about the evolution of magnetic fields in massive stars as they approach the end of their lives. As stars like VY Canis Majoris expand and cool, their magnetic fields undergo significant changes, potentially influencing the star's final stages and ultimate fate. These insights are helping astronomers refine models of stellar evolution and better understand the life cycles of the most massive stars in the universe. VY Canis Majoris, one of the largest known stars in our galaxy, serves as a crucial laboratory for studying stellar atmospheres. This hypergiant star, located in the constellation Canis Major, offers astronomers a unique opportunity to observe extreme stellar conditions that push the boundaries of our understanding. The sheer size of VY Canis Majoris creates an extended atmosphere that is more accessible to detailed observation than those of smaller stars. This allows scientists to study the complex interactions between radiation, gas, and dust in stellar environments. The star's atmosphere exhibits intricate structures, including massive outflows and ejections of material, which provide insights into the processes of stellar mass loss and the late stages of stellar evolution. Spectroscopic analysis of VY Canis Majoris reveals a rich chemical composition in its atmosphere, including the presence of various molecules and dust particles. This information helps astronomers refine models of element production and distribution in massive stars, contributing to our broader understanding of galactic chemical evolution. Furthermore, the study of VY Canis Majoris challenges existing stellar evolution theories, as its extreme properties test the limits of our models. By observing and analyzing this extraordinary star, scientists can improve their understanding of the physical processes governing the structure and behavior of stellar atmospheres across a wide range of stellar masses and ages. VY Canis Majoris, a hypergiant star in the constellation Canis Major, offers astronomers a rare glimpse into the extreme upper limits of stellar mass and size. This colossal star, with a radius estimated to be around 1,500 times that of our Sun, pushes the boundaries of our understanding of stellar physics. The sheer scale of VY Canis Majoris demonstrates that stars can grow to sizes far beyond what was once thought possible. Its enormous mass, believed to be around 17 times that of our Sun, showcases the delicate balance between gravitational collapse and outward radiation pressure that allows such massive stars to exist, albeit briefly in cosmic terms. Studying VY Canis Majoris helps scientists refine theories about stellar evolution and the processes that occur in the most massive stars. Its unstable nature, characterized by significant mass loss and powerful stellar winds, provides insights into how these giants influence their surrounding space and eventually meet their explosive end as supernovae. The existence of stars like VY Canis Majoris also raises questions about the theoretical upper mass limit for stars. While current models suggest a limit around 150 solar masses, observations of these hypergiant stars continue to challenge our understanding and push us to explore new possibilities in stellar formation and evolution. VY Canis Majoris, one of the largest known stars in our galaxy, offers astronomers a unique opportunity to study energy transport in extreme stellar environments. This hypergiant star, with its enormous size and intense luminosity, pushes the boundaries of our understanding of stellar physics. The sheer scale of VY Canis Majoris creates internal conditions that challenge conventional models of energy transport in stars. Its vast radius means that energy generated in its core must travel an immense distance to reach the surface. This journey involves a complex interplay of radiative transfer and convection, the two primary mechanisms of energy transport in stars. In the deep interior of VY Canis Majoris, energy moves primarily through radiative transfer, with photons gradually working their way outward. However, as we move towards the outer layers, convection becomes increasingly important. The extreme luminosity of the star drives powerful convective currents, creating massive cells that efficiently transport energy to the surface. These convective processes are so vigorous that they likely contribute to the star's prodigious mass loss rate. Studying VY Canis Majoris helps astrophysicists refine their models of stellar structure and evolution, particularly for the most massive stars. It provides a real-world test case for theories of energy transport under extreme conditions, informing our understanding of the life cycles of stars and the processes that shape the chemical evolution of galaxies. VY Canis Majoris serves as a crucial test subject for our understanding of stellar evolution, particularly for the most massive stars in the universe. This hypergiant star, located in the constellation Canis Major, is one of the largest known stars and presents a unique opportunity for astronomers to study the late stages of stellar life for extremely massive stars. The sheer size and luminosity of VY Canis Majoris challenge our models of stellar structure and evolution. Its enormous mass, estimated to be around 40 times that of our Sun, pushes the boundaries of what we thought possible for stellar formation and survival. By observing this stellar giant, scientists can refine their theories about the physical processes occurring within these extreme stellar environments. One of the most intriguing aspects of VY Canis Majoris is its intense mass loss rate. The star is shedding material at an astonishing pace, creating a complex circumstellar environment. This rapid mass loss provides valuable insights into the final stages of massive star evolution and the mechanisms that drive stellar winds in these extraordinary objects. Furthermore, studying VY Canis Majoris helps astronomers better understand the precursor states of supernovae and the formation of stellar remnants like neutron stars and black holes. As we continue to observe and analyze this cosmic behemoth, we gain crucial data that either confirms or challenges our existing models of how the most massive stars in the universe live and die. VY Canis Majoris, one of the largest known stars in our galaxy, serves as an exceptional laboratory for studying stellar pulsations. This hypergiant star, with its enormous size and dynamic nature, allows astronomers to observe pulsation phenomena on a grand scale, providing valuable insights into the internal processes of massive stars. The study of VY Canis Majoris reveals complex patterns of pulsations that occur throughout its immense structure. These pulsations, which are essentially waves propagating through the star's interior, cause variations in the star's brightness, temperature, and size. By analyzing these fluctuations, scientists can probe the star's internal composition and structure, gaining a deeper understanding of the physical processes occurring within massive stars. Observations of VY Canis Majoris have shown that it undergoes both regular and irregular pulsations, with periods ranging from days to years. This variety of pulsation modes offers a unique opportunity to test and refine stellar models, particularly those related to the late stages of stellar evolution in very massive stars. The data gathered from studying VY Canis Majoris helps astronomers improve their understanding of stellar physics, including the complex interplay between radiation pressure, gravity, and magnetic fields in extreme stellar environments. Furthermore, the pulsations observed in VY Canis Majoris provide clues about the star's mass loss mechanisms, which are crucial for predicting the ultimate fate of such massive stars. By studying these pulsations, scientists can better understand how these gigantic stars shed their outer layers and evolve, potentially leading to more accurate predictions about their lifespans and the types of supernovae they might produce. VY Canis Majoris, one of the largest known stars in our galaxy, offers astronomers a unique window into the dramatic processes of stellar mass loss. This hypergiant star, located in the constellation Canis Major, is shedding enormous amounts of material into space, providing crucial insights into the late stages of stellar evolution for the most massive stars in the universe. The extensive mass loss observed in VY Canis Majoris occurs through powerful stellar winds and episodic outbursts. These processes are so intense that the star is surrounded by a vast, complex nebula of ejected material. By studying this nebula and the ongoing mass loss, scientists can better understand the mechanisms that drive such extreme stellar behavior. Observations of VY Canis Majoris reveal that mass loss in hypergiant stars is not a smooth, continuous process. Instead, it occurs in sporadic, violent episodes. This pattern suggests that internal instabilities play a significant role in driving mass loss, challenging our previous models of stellar evolution for the most massive stars. Furthermore, the study of VY Canis Majoris highlights the critical role of mass loss in determining the ultimate fate of massive stars. As these stars shed their outer layers, they alter their evolutionary path, potentially avoiding a supernova explosion and instead ending their lives as smaller, hotter stars. This process reshapes our understanding of stellar life cycles and the chemical enrichment of the interstellar medium. VY Canis Majoris and Betelgeuse are both extraordinary stars that dwarf our Sun in size and brilliance. VY Canis Majoris, located in the constellation Canis Major, is a hypergiant star that ranks among the largest known stars in the universe. Its immense size surpasses even that of Betelgeuse, with estimates suggesting it could be up to 1,500 to 2,000 times the radius of our Sun. Betelgeuse, a red supergiant in the constellation Orion, is also a colossal star but not quite as large as VY Canis Majoris. Betelgeuse measures approximately 1,000 times the radius of our Sun, making it smaller than VY Canis Majoris, but still vastly larger than most stars we observe. Both stars are nearing the end of their stellar lives and exhibit variable brightness. VY Canis Majoris is classified as a luminous red hypergiant, while Betelgeuse is a red supergiant. These classifications reflect their enormous sizes and cool surface temperatures. However, VY Canis Majoris is significantly more luminous than Betelgeuse, emitting hundreds of thousands of times more energy than our Sun. The fate of these stellar giants differs slightly. VY Canis Majoris, being more massive, is expected to end its life in a spectacular supernova explosion, potentially leaving behind a black hole. Betelgeuse, while also destined for a supernova, might instead form a neutron star. These cosmic behemoths serve as captivating examples of the extreme scales and diverse life cycles found in our universe. VY Canis Majoris and UY Scuti are both extraordinary stars that push the boundaries of our understanding of stellar evolution. These celestial giants share several key characteristics while also exhibiting notable differences. Both stars are classified as red hypergiants, representing some of the largest and most luminous stars known in the universe. They exist at the extreme end of stellar size, with diameters so vast that they challenge our ability to comprehend cosmic scale. If placed at the center of our solar system, either star would engulf the orbit of Jupiter. However, UY Scuti currently holds the title of the largest known star in the universe, surpassing VY Canis Majoris in size. While precise measurements are challenging due to their distance and dynamic nature, astronomers estimate that UY Scuti's radius is approximately 1,708 times that of our Sun. VY Canis Majoris, once thought to be the largest, is now estimated to be slightly smaller but still enormously massive. Another key difference lies in their location and visibility. VY Canis Majoris resides in the constellation Canis Major and is visible from Earth, albeit only through powerful telescopes. UY Scuti, on the other hand, is located in the constellation Scutum and is much farther away, making it more challenging to observe and study in detail. VY Canis Majoris stands out as a true giant among the stars in the Canis Majoris constellation. This hypergiant star dwarfs not only its stellar neighbors but also our own Sun, showcasing the incredible diversity of stellar objects in our galaxy. To put its size into perspective, If VY Canis Majoris were placed at the center of our solar system, its surface would extend beyond the orbit of Jupiter. This makes it one of the largest known stars in the universe, with a radius estimated to be around 1,500 times that of our Sun. In terms of brightness, VY Canis Majoris outshines many of its constellation companions. However, due to its extreme distance from Earth, approximately 3,900 light-years away, it appears relatively faint to the naked eye. This serves as a reminder of the vast scales involved in cosmic distances and the limitations of our earthbound perspective. The star's enormous size and luminosity place it in a rare category of stars known as red hypergiants. These celestial behemoths are nearing the end of their stellar lives, making VY Canis Majoris a fascinating subject for astronomers studying the late stages of stellar evolution. Its eventual fate, likely as a supernova, will far outshine any other star in Canis Majoris, briefly becoming one of the brightest objects in our night sky. Comparing VY Canis Majoris to smaller hypergiant stars provides valuable insights into stellar evolution and the extreme limits of star size. VY Canis Majoris, one of the largest known stars in the universe, dwarfs many other hypergiants, showcasing the incredible diversity within this rare class of stars. By examining VY Canis Majoris alongside smaller hypergiants, astronomers can better understand how these massive stars form, evolve, and eventually die. The stark size difference highlights the role of initial mass and composition in determining a star's ultimate fate. While all hypergiants are exceptionally large, the sheer scale of VY Canis Majoris suggests it may have unique properties or formation history. These comparisons also reveal important information about stellar atmospheres and mass loss rates. Hypergiants, like VY Canis Majoris, experience intense stellar winds, shedding enormous amounts of material into space. By studying how this process differs between VY Canis Majoris and its smaller counterparts, scientists gain crucial knowledge about the life cycles of massive stars and their impact on galactic chemistry. Furthermore, such comparisons help refine our models of stellar physics, pushing the boundaries of our understanding of how stars behave at the extreme end of the size spectrum. This knowledge not only enhances our grasp of stellar evolution, but also provides valuable insights into the cosmic processes that shape our universe. VY Canis Majoris, one of the largest known stars in our galaxy, exhibits an extraordinary mass loss rate that surpasses most other massive stars. This red hypergiant sheds an immense amount of material into space, far exceeding the typical rates observed in other stellar giants. To put this in perspective, VY Canis Majoris loses mass at a rate of approximately 30 to 60 times the mass of Earth every year. This is orders of magnitude greater than the mass loss experienced by our Sun, which only loses about the mass of Earth every 150 million years through its solar wind. Compared to other massive stars, such as the well-known Betelgeuse, VY Canis Majoris still stands out. Betelgeuse, itself a red supergiant, loses mass at a rate of about 1 Earth mass per year, which is significant, but pales in comparison to VY Canis Majoris. Even among the most massive known stars, like Eta Carinae, VY Canis Majoris remains exceptional in its prodigious mass loss. This extreme mass loss rate has profound implications for the star's evolution and ultimate fate. It suggests that VY Canis Majoris is in the final stages of its life, rapidly shedding its outer layers before it potentially explodes as a supernova or collapses directly into a black hole. Comparing VY Canis Majoris to Wolf-Rayet stars reveals fascinating insights into the diverse life cycles of massive stars. VY Canis Majoris is a red hypergiant, one of the largest known stars in the universe, while Wolf-Rayet stars are hot, luminous, and rapidly losing mass through intense stellar winds. Both types of stars represent different stages in the evolution of very massive stars. VY Canis Majoris, with its enormous size and cooler temperature, showcases the extreme expansion that can occur in the late stages of a star's life. Wolf-Rayet stars, on the other hand, have shed their outer layers, exposing their hot, helium-burning cores. This comparison highlights the various paths massive stars can take as they approach the end of their lives. While VY Canis Majoris maintains its extended envelope, Wolf-Rayet stars have lost theirs, demonstrating the significant role that mass loss plays in stellar evolution. The study of these contrasting stellar types helps astronomers understand the complex processes that shape the life and death of the most massive stars in our universe. Furthermore, both VY Canis Majoris and Wolf-Rayet stars contribute significantly to the enrichment of the interstellar medium with heavy elements, albeit through different mechanisms. This comparison underscores the crucial role massive stars play in the chemical evolution of galaxies, regardless of their specific evolutionary path. VY Canis Majoris stands out as one of the most luminous stars known in our galaxy. This red hypergiant shines with the brightness of several 100,000 suns, making it an extraordinary beacon in the cosmos. Its immense energy output dwarfs that of many other stars considered extremely bright. To put its brilliance into perspective, VY Canis Majoris outshines even the famous blue supergiant Rigel, one of the brightest stars visible to the naked eye. While Rigel emits the light of about 40,000 suns, VY Canis Majoris surpasses this by nearly tenfold. The energy radiating from this stellar titan is so intense that if it were to replace our Sun, it would outshine the full moon even from as far away as Neptune. Compared to other hypergiant stars, VY Canis Majoris holds its own in terms of luminosity. It rivals the brightness of stars like UY Scuti and RW Cephei, fellow members of the elite club of extremely luminous stars. However, it's worth noting that some stars, such as the blue hypergiant Roan 136 in the Large Magellanic Cloud, may surpass VY Canis Majoris in total energy output. The extreme luminosity of VY Canis Majoris and its hypergiant peers comes at a cost. These stars burn through their fuel at an astounding rate, leading to relatively short lifespans in cosmic terms. Their intense brightness serves as a prelude to their eventual spectacular demise as supernovae, events that will briefly outshine entire galaxies. Comparing VY Canis Majoris to younger massive stars provides valuable insights into the life cycles of the most enormous stars in our universe. VY Canis Majoris is a hypergiant star, one of the largest known stars in the Milky Way, and its study offers a glimpse into the future of younger, massive stars. This celestial behemoth is nearing the end of its life, having expanded to an enormous size as it burns through its nuclear fuel. By observing VY Canis Majoris, astronomers can better understand the late stages of stellar evolution for massive stars. Its bloated, unstable nature and intense mass loss through stellar winds showcase the tumultuous end that awaits other massive stars. Younger massive stars, in contrast, are still in their prime, fusing hydrogen in their cores and maintaining a more stable structure. By comparing these youthful giants to VY Canis Majoris, scientists can track the changes that occur as massive stars age. This comparison reveals how stellar composition, size, temperature, and brightness evolve over millions of years. Furthermore, studying VY Canis Majoris alongside its younger counterparts helps astronomers refine models of stellar evolution, improving our ability to predict the fates of other massive stars in our galaxy and beyond. This knowledge is crucial for understanding the cosmic processes that shape our universe, from the formation of heavy elements to the occurrence of supernovae. VY Canis Majoris, one of the largest known stars in our galaxy, shares many chemical similarities with other hypergiant stars, but also exhibits some unique characteristics. Like most hypergiants, it is primarily composed of hydrogen and helium, the two most abundant elements in the universe. However, spectroscopic analysis has revealed a rich array of heavier elements in its outer layers. The atmosphere of VY Canis Majoris contains significant amounts of oxygen, carbon, and nitrogen, which are products of advanced stellar nucleosynthesis. These elements are also found in other hypergiant stars. But VY Canis Majoris shows particularly strong emission lines of these elements, indicating their abundance. Interestingly, This star also displays an unusually high concentration of sulfur compounds, setting it apart from many of its hypergiant counterparts. Another notable feature of VY Canis Majoris is its substantial envelope of dust and gas, rich in complex molecules. Observations have detected the presence of water vapor, silicon oxide, and even organic compounds in this extended atmosphere. This molecular complexity is not unique to VY Canis Majoris, but is more pronounced than in many other hypergiant stars. The chemical composition of VY Canis Majoris reflects its advanced evolutionary state. As the star nears the end of its life, it is rapidly losing mass through powerful stellar winds, enriching its surroundings with heavy elements. This process of element dispersion is common among hypergiant stars, but the sheer scale and rate at which it occurs in VY Canis Majoris make it a fascinating subject for astronomers studying stellar evolution and galactic chemical enrichment. VY Canis Majoris, one of the largest known stars in our galaxy, offers astronomers a unique opportunity to study the life cycles of massive stars. By comparing its fate to that of other giant stars, we gain valuable insights into stellar evolution and the ultimate destinies of these cosmic behemoths. One key lesson from VY Canis Majoris is the intense mass loss experienced by hypergiant stars. As these stars age, they shed enormous amounts of material into space, creating vast nebulae around themselves. This process is much more pronounced in stars like VY Canis Majoris, compared to smaller, less massive stars, highlighting the extreme nature of these stellar giants. The fate of VY Canis Majoris also sheds light on the different paths massive stars can take in their final stages. While some massive stars end their lives in spectacular supernova explosions, others, like VY Canis Majoris, might instead collapse directly into black holes without a visible supernova. This variation in stellar fates helps astronomers refine their models of stellar evolution and better understand the factors that determine a star's end-of-life scenario. Furthermore, studying VY Canis Majoris and its counterparts provides crucial information about the chemical enrichment of the universe. These massive stars produce and distribute heavy elements throughout their lives and deaths, playing a vital role in cosmic chemistry and the formation of future generations of stars and planets. The discovery of VY Canis Majoris has significantly expanded our understanding of stellar evolution and the upper limits of star sizes. This hypergiant star, located in the constellation Canis Major, is one of the largest known stars in the universe. Its immense size, estimated to be between 1,400 and 2,600 times the radius of our Sun, has challenged previous models of stellar formation and growth. Astrophysicists have had to reconsider theories about the maximum possible size of stars and the processes that allow such enormous celestial bodies to form and exist. The study of VY Canis Majoris has provided valuable insights into the late stages of stellar evolution for very massive stars. Its unstable nature and high mass loss rate offer a unique opportunity to observe and analyze the processes that occur as these giants approach the end of their lives. The star's extreme luminosity and size have also prompted researchers to investigate the physical limits of stellar structures. This has led to advancements in our understanding of stellar atmospheres, internal stellar dynamics, and the complex interplay between gravity and radiation pressure in supermassive stars. Furthermore, the discovery of VY Canis Majoris has spurred interest in searching for and studying other hypergiant stars. This has resulted in the identification of several other extremely large stars, helping to populate the upper end of the stellar mass and size spectrum. These findings continue to refine our knowledge of stellar populations and their role in galactic evolution. The study of VY Canis Majoris, one of the largest known stars in our galaxy, has opened up several intriguing avenues of research in astrophysics. This hypergiant star, located approximately 3,800 light-years from Earth, has challenged our understanding of stellar evolution and the upper limits of stellar mass. One key question that has emerged is how such massive stars maintain their stability. VY Canis Majoris is estimated to be 30 to 40 times the mass of our Sun, pushing the boundaries of what we thought possible for stellar mass. Scientists are now investigating the internal mechanisms that allow such enormous stars to exist without immediately collapsing under their own gravity. Another area of research focuses on the intense mass loss observed in VY Canis Majoris. The star is surrounded by an extensive envelope of ejected material, prompting questions about the processes driving this extreme stellar wind. Researchers are exploring how this mass loss affects the star's evolution and its eventual fate. The study of VY Canis Majoris has also sparked interest in the role of such massive stars in galactic chemical evolution. As these stars end their lives, they seed their surroundings with heavy elements. Understanding the life cycles of hypergiant stars could provide crucial insights into the chemical enrichment of galaxies throughout cosmic history. VY Canis Majoris has significantly expanded our understanding of stellar classification, particularly when it comes to the upper limits of stellar size and mass. This hypergiant star, located in the constellation Canis Major, is one of the largest known stars in the universe, with a radius estimated to be around 1,500 times that of our Sun. The study of VY Canis Majoris has forced astronomers to reconsider the traditional stellar classification system. Its enormous size and extreme luminosity push the boundaries of what we thought possible for stellar evolution. This star falls into the rare category of red hypergiant stars, a classification that was not well understood until relatively recently. Observations of VY Canis Majoris have revealed complex behaviors and structures that challenge our models of stellar physics. Its massive size leads to instabilities and intense mass loss, creating a surrounding nebula that provides valuable insights into the late stages of stellar evolution for very massive stars. Furthermore, the existence of stars like VY Canis Majoris has led to refinements in our understanding of the Hertzsprung-Russell diagram, which classifies stars based on their luminosity and temperature. This star occupies an extreme position on this diagram, helping astronomers better define the upper limits of stellar parameters and improving our overall comprehension of stellar life cycles and the diversity of stars in our universe. VY Canis Majoris, one of the largest known stars in the universe, has significantly influenced our understanding of stellar evolution and the upper limits of star formation. This hypergiant star, located in the constellation Canis Major, has challenged previous models of how massive stars form and evolve. The sheer size of VY Canis Majoris, estimated to be between 1,500 and 2,600 times the radius of our Sun, has forced astronomers to reconsider the mechanisms that allow stars to grow to such enormous proportions. Traditional theories of star formation struggle to explain how a star could accumulate so much mass without becoming unstable and breaking apart. Observations of VY Canis Majoris have revealed complex structures in its surrounding environment, including massive outflows and ejections of material. These features have provided valuable insights into the late stages of stellar evolution for extremely massive stars, helping scientists refine their models of stellar death and the processes that lead to supernovae. The study of VY Canis Majoris has also contributed to our understanding of stellar atmospheres and the role of convection in massive stars. Its extreme luminosity and size have made it an ideal target for studying the physics of stellar interiors and the mechanisms that drive stellar winds in the most massive stars in the universe. VY Canis Majoris has significantly expanded our understanding of stellar evolution, particularly for massive stars. This hypergiant star, one of the largest known in our galaxy, serves as a crucial laboratory for studying the late stages of stellar life. Observations of VY Canis Majoris have revealed intense mass loss rates, shedding light on how massive stars shed their outer layers as they approach the end of their lives. This process is key to understanding how these giants enrich the interstellar medium with heavy elements, contributing to the chemical evolution of galaxies. The star's extreme size and luminosity have also challenged existing stellar evolution models. Scientists have had to refine their theories to account for stars that reach such enormous proportions, leading to improved models of stellar structure and evolution for the most massive stars in the universe. Furthermore, studying the complex environment around VY Canis Majoris, including its extensive nebula and dust clouds, has provided insights into the interactions between massive stars and their surroundings. This knowledge enhances our comprehension of stellar wind dynamics and the formation of circumstellar environments. VY Canis Majoris, one of the largest known stars in our galaxy, has been instrumental in advancing observational techniques in astronomy. This hypergiant star, located approximately 3,900 light-years from Earth, has challenged our understanding of stellar evolution and pushed the boundaries of our observational capabilities. The sheer size and complexity of VY Canis Majoris have necessitated the development of more sophisticated imaging techniques. Astronomers have utilized adaptive optics systems, which correct for atmospheric distortions, to obtain clearer and more detailed images of the star and its surrounding environment. These advancements have not only benefited the study of VY Canis Majoris, but have also been applied to observations of other celestial objects. Furthermore, the study of VY Canis Majoris has driven improvements in spectroscopic methods. The star's intense mass loss and complex circumstellar environment have required the development of more sensitive spectrographs and data analysis techniques. These enhancements have allowed astronomers to better understand the chemical composition and physical processes occurring in and around the star. The extreme nature of VY Canis Majoris has also prompted astronomers to combine multiple observational techniques, such as interferometry and high-resolution spectroscopy. This multi-wavelength approach has become increasingly common in studying other astronomical phenomena, demonstrating how the challenges posed by this massive star have led to broader advancements in observational astronomy. VY Canis Majoris, one of the largest known stars in our galaxy, has significantly shaped our understanding of galactic chemical evolution. This hypergiant star, located in the constellation Canis Major, serves as a cosmic laboratory for studying the life cycles of massive stars and their impact on the chemical enrichment of the universe. As an extremely massive star nearing the end of its life, VY Canis Majoris produces and ejects vast quantities of heavy elements into space. These elements, forged in the star's core through nuclear fusion and during its eventual supernova explosion, are crucial for the formation of new stars, planets, and even life itself. By studying the composition and behavior of VY Canis Majoris, astronomers have gained valuable insights into the processes that distribute these elements throughout the galaxy. The star's enormous size and high mass loss rate have allowed scientists to observe and analyze the chemical composition of its outer layers in unprecedented detail. This has provided crucial data on element production in massive stars and how these elements are dispersed into the interstellar medium. Such information is vital for refining models of galactic chemical evolution and understanding how successive generations of stars have gradually enriched our galaxy with heavier elements. Furthermore, VY Canis Majoris has challenged existing stellar evolution theories, prompting scientists to reconsider the upper limits of stellar mass and the complex processes occurring in the final stages of massive star life cycles. This has led to a more nuanced understanding of how the most massive stars contribute to the ongoing chemical enrichment and evolution of galaxies across the universe. VY Canis Majoris, one of the largest known stars in our galaxy, has significantly influenced our understanding of stellar structure and evolution. This hypergiant star has challenged existing computational models, forcing astronomers to refine their simulations and theories. The sheer size of VY Canis Majoris, with a radius estimated to be over 1,000 times that of our Sun, pushes the boundaries of what we thought possible for stellar mass and volume. This extreme case has required scientists to adapt their models to account for the intense radiation pressure and complex internal dynamics present in such massive stars. Computational models have had to be adjusted to incorporate the effects of extreme mass loss and unstable outer layers observed in VY Canis Majoris. These phenomena are crucial for understanding the life cycles of the most massive stars in the universe. The star's unusual properties have also led to improvements in modeling stellar atmospheres and the complex interactions between a star's radiation and its surrounding dust and gas. Furthermore, Canis Majoris has prompted researchers to refine their simulations of stellar evolution for stars at the upper end of the mass spectrum. This has implications for our understanding of supernovae, the formation of heavy elements, and the ultimate fate of the most massive stars in the cosmos. Canis Majoris, a hypergiant star in the constellation Canis Major, has significantly advanced our understanding of supernova processes and the life cycles of massive stars. This colossal star, estimated to be up to 2,000 times the size of our Sun, provides astronomers with a unique opportunity to study the late stages of stellar evolution in real time. Observations of Canis Majoris have revealed intense mass loss and powerful stellar winds, key processes that shape the final stages of a massive star's life. These phenomena offer crucial insights into the mechanisms that lead to supernova explosions. By studying the complex atmosphere and outflows of this star, scientists have gained a better understanding of how massive stars shed their outer layers before their eventual collapse. The extreme size and luminosity of Canis Majoris also allow astronomers to examine the chemical composition of its atmosphere in great detail. This information is vital for predicting the types of elements that will be produced and dispersed into space when the star eventually explodes as a supernova. Such data helps refine models of stellar nucleosynthesis and improves our understanding of how supernovae enrich the interstellar medium with heavy elements. Furthermore, the study of Canis Majoris has challenged existing theories about the upper mass limits of stars and the conditions necessary for different types of supernova explosions. As astronomers continue to monitor this extraordinary star, they hope to witness and document the precursor events leading up to a supernova, providing unprecedented insights into these cosmic cataclysms. The study of Canis Majoris has significantly expanded our understanding of massive stars and their evolution. This hypergiant star, one of the largest known in our galaxy, has become a crucial laboratory for astrophysicists exploring the extreme limits of stellar physics. Research on Canis Majoris has led to new insights into the complex processes of mass loss in giant stars. Scientists have observed extensive dust clouds and molecular outflows surrounding the star, providing valuable data on how these enormous celestial objects shed material throughout their lifetimes. This information is crucial for understanding the later stages of stellar evolution and the enrichment of the interstellar medium. The star's immense size and luminosity have also prompted advancements in stellar modeling techniques. Researchers have had to refine their computational models to account for the extreme conditions found in such massive stars, leading to improvements in our overall understanding of stellar structure and dynamics. Furthermore, studying Canis Majoris has opened up new avenues in the field of astrochemistry. The star's extended atmosphere has been found to contain a rich variety of molecules, allowing scientists to investigate chemical processes under conditions not replicable on Earth. This research contributes to our knowledge of element formation and distribution in the universe, connecting the life cycles of stars to the broader cosmic environment.